Hello. Hey everyone. How you guys doing? Hope everyone is doing well. Um alright, so what I would like to do today is jump into version control systems and Git and GitHub and what they are and how they're extremely useful to use as a programmer. So I'm gonna take a very small break from SFML and set that up for you guys. Um, I know it's kind of exciting that we had a circle on the screen and a rectangle, and we wanted to have a sprite. We'll do that today at the end of the lecture, but I want to get the boring part out, which is Git. It's never as exciting as having, working on the actual game, but it's essential that we set up Git and we configure it and we use it. Um, all right, so what is Git? Or what's a version control system? Well, let me explain it this way. Imagine um, you're trying to add a feature to your game, right? Imagine you're trying to add a uh, rectangle in your game, and you've added some code, you worked all day, and somehow you messed up the code. Somehow the game now doesn't run at all. It doesn't compile, it doesn't link, and there's something seriously wrong in the project. And you want to go back in time, you want to go back to your old code. Um, Let me give you another example. What if one day you're working on your project and the electricity shut off? And when it turned back on, an hour later or a few minutes later, you discovered that your entire project was corrupted and files were deleted. Now that's a really big problem because all your hard work is in a single place. Now, to get this out of the way, first of all, you have to, for the love of God, please, I'm begging you, back up your data. It is unbelievably essential that you back up your data. Your data is the most important thing in your life. You have to back them up to at least three places. One place in your computer. So you have your data in your computer. Back them up into an external hard drive or another computer, or have a backup server at home. I have a backup server that is always running, that always backs up my data daily when I go to bed. And have a third place like a cloud storage. So either Google Drive, OneDrive. What is that other service that used to be famous but no one uses? Dropbox. Yeah, I think Dropbox. I haven't heard that. I don't know what the hell is going on with that company. I don't know if it's actually running or not. But the point is, put your data also on the cloud. So in case your computer dies and your server dies, you have a third place. Let's say your house was set on fire for whatever reason, and both your computer and server are gone. Your data is at least or somewhere outside on the cloud in some server. Your data is extremely essential. Please, if you haven't backed up your data, for the love of God, back up your data. It is really important. All right, with that public service announcement out of the way, going back to our example of you lost some files and now you're kind of screwed. Well, what do we do? Well, the what I used to do before when I was in college and before getting introduced to Git and GitHub and all these version control systems, what I used to do essentially, this is my project, right? Over here. It's called RPG game. What I would do is I would use WinRAR, and if you don't know what WinRAR is, it's a program that compresses your data into one folder. So this is like one file that has multiple files in it, and it compresses it, so it saves space and it just puts everything in one place, right? So what I used to do is go here, click on add to archive, and then either I can compress it with either WinRAR or WinZip, and compression, I'll pick the best method and press OK, right? And now it's compressing my data. It's compressing all of my data. Visual Studio is running, so it's not happy with me compressing my data. Whatever, it's good enough. I don't actually care that it didn't compress it very well. But here, I have my RPG. So now what I do is name it V1, right? And then if I do some work on the project, I do the same thing every day, and I have version 2, version 3, version 4, version 5. And it got to a point where my project was my simple project that is supposed to be 50 MB is now like 1.5 GB because I have multiple versions of the same project, multiple backups. And so if I wanted to go to my previous code, let's say when I first started the project, I go to version 1. Or if something went wrong, I go to a previous version, right? So you could do that to kind of save your code multiple times every day, right? That's one way you can do it. There's a horrible way of doing it, right? We have much better tools. We've had much better tools in the 90s, in the 80s. I believe Git was when was it Git introduced? Google Git release date. So Git initial release date is 2005, but I'm pretty sure there's some sort of version control that came out first version control release date ever. 1982, right? And it was Git. It's written in C. Yeah, it was CVS or something along these lines. It was on Unix. But we had software and systems that allows us to have multiple versions of our code. So if we want to go back in time, we can. So essentially a version control system or a version control software is it literally saves your code at a certain point in time. Just like how you would play a game and you would have multiple saves in that game. And if you want to go to a specific level, you to a specific point or a specific save, you just load that save. It's the same exact thing, same concept. Version control systems allow you to save your code in multiple points in time, which is super, super cool. And we have to set that up because if we mess something up, or if someone wants to use the code, they can do it easily, right? All right, so let's do that boring part. So the version control, there are a lot of version control systems out there. There's Git, there's Preforce. I hear Preforce is very popular in the games industry. I've never personally used it. I've only used Git. There's SVC or CSVC or something along these lines. Version control systems. Right, there's Git, there's Apache Subversion, Mercurial, Preforce, and a bunch of them. There's apparently hundreds of them. Oh, it's cool, rat. There are a lot of them, right? The one we're going to use, which is the most popular one, is Git. Git. Git is a version control system. I think it was built on top of Linux, and it was built by the guy who made Linux, if I'm not wrong. So it's written by, yeah, I could be wrong. Maybe not Linus. It was written by someone. It doesn't matter. But Git is our version control system, and we're going to use it. Now, Git on its own, it's a command line interface. It's a command line software, meaning it looks like this. You have a black screen, right? That's our command line, and we've seen the command line before. So if I press play here, right, you would see that this is the command line. This is my command line over here, right? So to use Git, it's a command line interface, and in order for you to use it, you have to write commands. We're gonna use that a little bit, and the command line is super fast, but you have to remember instructions and It's not very beginner friendly, but we're still going to use it for a little bit. At the same time, we're going to use a GUI interface for Git, or a graphical user interface for Git. Now, there's multiple graphical user interfaces to use Git. There's source tree. Source tree looks like this, right? It's just a user interface to use the actual system, which is Git. Source tree itself is beyond horrendous. It is the worst application I've ever used in my entire life. It crashes a lot, it freezes a lot, it doesn't make sense, there's a lot of problems with it, and it's made by a multi-billion company. Multi-billion-dollar company. So I don't know how can you mess up a software as bad as they do. So source tree is bad. It's really, really bad. Alternatively, there's other alternatives. There's like Git Kraken. Git Kraken is really nice. It has a dark theme. It looks really pretty. And apparently it's good and it's very advanced and has a lot of cool features. The problem is there's a free version and there's a paid version. The free version is useless, and you have to use the paid version in order for you to do, well, anything advanced, which sucks. So we're not using Git Kraken, even though it's really, really pretty. It's really nice. So our third option is something called Git-Fork. Git-Fork, Git-Fork over here, is an awesome GUI interface for Git. I think it's made by 2 people. Yeah, it's literally made by 2 people. And it's more stable than Source Tree, which is a software made by a multi-billion-dollar company. Makes zero sense to me, but here we are. It is really, really awesome. It's free. You can use it. You can buy the license if you want. You can pay $50 to buy the license. The license doesn't do anything for you. The license, the only reason you would buy the license is to support these guys and be like, hey, awesome job. It doesn't give you any features. It doesn't unlock anything in the app. Everything in the free version exists in the paid version. There's literally no difference. You just, you give them a bit of money, which is cool, right? So we're gonna download the free version of it, which is awesome. All right. So what do we need? Well, the first thing we need, oops, I closed that tab. Can I reopen it, please? Reopen, close tab. Thank you. So the first thing we need the actual software, Git, the actual system, right? Now, when you download Git-Fork, it will install Git for you. It will come with Git. But what I usually like to do is have Git installed separately and Git-Fork installed separately. And the reason for that is if I want to use the terminal or user interface, I can. And if I want to update this separately, I can. And if I want to update this software separately, I can. It's just a preference that I have, and I highly recommend just kind of following what I'm doing, basically. All right, so first we start with Git. So download for Windows. If you're on Windows, Mac, or Linux, doesn't matter which operating system you're on, you can download it. So what I'm going to do is click on download. To get to this point, you just literally type git, git, and it's git scm.com. Go to downloads, and you can or go to the homepage and just click on download for Windows. Now, by default, it's going to download the 64-bit version and make sure it's downloading the 64-bit version. For whatever reasons, if it's downloading 32-bit, which I don't think it's going to do, but for whatever reason, if it is, make sure you're downloading the 64-bit version. It tells you here whether you're downloading 32 or 64. In my case, it's 64. Anyways, it's downloading. It's doing its thing. For whatever reason, it's really, really slow. What the hell's going on with my internet? So we'll let it download for a while. While it's downloading, at the same time, I would like to download Fork. So on the right here, download Fork for Windows. Let's do that. And now I have both Fork and Git downloading. Seriously, what is up with my internet? Why am I downloading at 300 KB per second? All right, well, that's interesting. Anyways, Okay, cool. So while these things are downloading, what I'm gonna do. So okay, Git is a version control system that you use on your local machine. So you can save your code at multiple points in time. And what usually happens is you write some code, you add a new feature, you save that code and save that feature, and then into the Git system, and then you go ahead and write some more code, and then save it, and then some more code, and then save it. What I usually do is when I'm done with my workday, I just save my code, then I go to bed, right? Um, so you can do that, or you can split. You can have multiple saves. You can have as many saves as you want. It doesn't matter. But what I usually do, write code when I'm done with a specific feature, or at the end of my day. I always do it at the end of my day, whether I'm done with the feature or not. Even if my code doesn't work, at the end of my day, I save it, and then I save it inside Git, and then I go to bed. Next morning, I continue working, right? So that's kind of the workflow that I usually do. All right, so let's see if this is done. It's still doing a thing. Now, like I mentioned, Git is the command line interface, like the black window, and Git-Fork is the GUI interface. And you're basically creating that, or you're saving your code on your local machine. What if we want to save our code online, right? And we want to push it online. How do we do that? Well, there are a bunch of options for that too. So the usual options is GitHub, which was recently bought by Microsoft. I don't think recently, it's been a year now, I think. They bought it last year. But GitHub is basically the web interface or the cloud version of Git, which you can upload your code to, which is cool. So now you have two backups, or you have a backup, one backup. Your code is on your machine, and you can upload it to the cloud at the same time. And it's really easy to do that, and I'm going to show you how to do it. So that's one option we have. We have GitHub. The other option is GitLab. GitLab is another company that basically do the same thing. It's cloud storage where you can upload your code to the cloud, right? Privately or publicly. Now, before Microsoft bought GitHub, you couldn't create a private repository. You couldn't work as a team privately. Your actual code has to be online for everyone to see publicly. But with and so GitLab, the advantage with GitLab was that you could create a private code that you only can see, or you can upload your code privately and only you can see it, which was awesome if you wanted to work something on some code privately. But then Microsoft bought GitHub, and now there's, as far as I know, there aren't any differences, except that GitHub is the most popular one. And so we're going to use GitHub rather than GitLab. You could use GitLab, nothing wrong with it. I actually use GitLab for my own game studio. So my own company, we use GitLab. For my personal work, I use GitHub. Either or, they work fine. In our case, we're going to use GitHub. So I'm going to create an account. I'm going to show you the entire process of creating an account and setting all that up. All right, so as far as I know here, Git installed, was downloaded, and Git-Fork was downloaded. As of the time of recording, the latest version is Git 2.33.1 and 64-bit. So I'm going to double click on it. I already have it installed, so is it just gonna? Oh, it's okay. Well, it's just gonna remove the previous Git. Right, well, it's removing the previous Git. Let that wait. We'll wait for that for a few seconds. This is elevator music. I hope you're enjoying it. All right, well, see, Git, I didn't want you to just, all right, program, uninstall program. Can I just delete it, please? Oh, I have so many. I'm just gonna walk you through the entire setup, right? So I'm gonna have to uninstall it. Yes, please. I would like to uninstall it. And I'm also gonna delete fork. I should go fresh. Thank you. Do I have to worry about anything about fork? No, just uninstall it. Da, 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 da. Okay, cool. All right, so double click on Git. Assuming you're installing it for the first time, it's gonna give you your license. Make sure to read it. Who the hell reads this? No one cares. You press next. No one reads this. Okay. Path. It's usually C program file Git. I wouldn't recommend changing it. Just keep it as default. Yes. All right. Additional icons. I like my additional icons, so I'm gonna download those. Check daily for Git updates. So I would like to get daily updates from Git, as in if they update the software, I get those updates. So I'm gonna check that. Add a Git bash profile to Windows Terminal. No, because Windows Terminal is fucking disgusting. So next. Nothing to do here. Next. Now you have a bunch of options for editors. There's Vim, Notepad++, Visual Studio Code, blah blah. I'm just gonna keep it on default Vim. And I'll teach you Vim at some point. It's a really important editor to learn, especially if you're doing later on in your career. You're doing some server work. If you want to edit code on an SSH, you want to SSH into a server and edit some code. Vim is a really powerful, and it exists everywhere. It's really fucking stupid. Vim is the worst editor that ever existed on Earth, but it's everywhere. It's fucking everywhere. So keep it at Vim. Let Git decide. Yeah, it doesn't matter. Let Git decide. So this is the branch. We'll talk about branches. Keep it at master. It doesn't matter. Git from Git batch third party. Yeah, sure. Why not? Doesn't matter. Open SSH is fine. Open SSL library is fine. We're gonna use the Windows style. That's fine. Yes, mini TTY is fine. Again, we'll talk about these later on. Pass forward or merge, that's fine. Git credential manager core, that's fine. That's fine. Not gonna do anything experimental, so thank you very much. And that's all. So basically, next. Every version of Git, they might give you new features, new options to select. These options might not be the same. I don't know, a year from now, 6 months from down the line. So this might look different. So just, next. That should be fine. Default options are great, right? Might as well, seeing that we're installing software, so let's just finish. All right, and there you go, finish. What I'd like to do is I'd like to pin all my mostly used development apps and mostly used apps on the taskbar. It's useful, so you can see have a bunch of things pinned. Might as well, since we're talking about softwares and things that help you development, Notepad++. Notepad++ is God's gift to society. Obviously, you have the free version or the horrible version. That's Notepad, comes with Windows, free of charge. And I believe they added a dark theme. No, they didn't. Right? It's all white. My eyes hurt. It's disgusting. So I highly recommend you download Notepad++. It's a text editor where you can write code and actually compile stuff in it. It doesn't come with a compiler, doesn't come with a linker, doesn't come with anything, just a text editor, but you can configure it to like debug and compile stuff and do things, right? So I highly recommend you download it and use it. It's nice if you want to write some notes. So Notepad++. There you go. It's fantastic. Latest release is fine. 64-bit is fine. So get that going. And if you wanna, so by default it's gonna be white. If you wanna change the color, you go to settings, style configurator. By default, it's gonna have the default style, which is white. Which, ouch, my eyes hurt. What I highly recommend, you type something, and then try change the themes. So I'm gonna click here, and I'm gonna use my up and down arrows. So down. This looks nice actually. And the reason I said write something here, so you can see what the text color is gonna look like. So this is nice. It's fine. Disgusting. 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 Very good. Disgusting. 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 Okay-ish. Okay-ish. Horrible. Horrible. Okay-ish. 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 Absolutely horrible. Fine. Very good. Nice. Horrible. Okay-ish. And you have much options, right? I would like to go with deep black, please. Blackboard? No. Deep black. Thank you so much. And there you go, which is kind of cool, right? Notepad++, highly recommended. Get it. Anyways, after we installed Git, right, you can open it if you type git, and you have, it's called Git Bash. If I click on it, it opens a terminal for you, right? This is called the min GW, which is just it's a command line. Rather than using the Windows command line, which is horrible, we can use this command line. All right, so we have the command line. We're gonna use it for a little bit, just a little, not now, but here it is. I highly recommend you pin it on your taskbar so you can use it again. But there it is. Oh, this is fork. No, please don't remove it. Do I not have it pinned? Oh, what a shame. Let's pin it right now. Git bash. Right click. I don't want to run as administrator. I'd like to pin you. Thank you, and move him to here. Close it. There you go. All right, so got my Git set up. Literally, realistically, that's all I need, and I can get started with the Git version control. But we want the GUI interface. The GUI interface is nice, so download it, install it. So let's go to downloads, click on fork installer, and let's install that baby up. All right, here's fork. You want to type your name. I usually just type my real name. All right, your email address. Usually type my email address. All right. Yeah, this is fine. Finish up, and that's really all you need to do. That's really it. Nothing more to it. And there you go. I have fork. It's gonna be light theme for you when you first install it. So on the top right section, appearances, select the dark theme. Looks really nice. And that's fork. All right, and we're gonna use fork and set everything up. All right, cool. So now that we have fork, we have Git. We're almost ready. I would like to set up I would like to set up GitHub, the online cloud solution thing, right? So I'm gonna create an account just to show you how that setup goes. Just to go sign up. Welcome to GitHub. Let's begin the adventure. Oh, that is super cool. Oh, that's sick. Microsoft, good job. All right, so I'm gonna use a temporary email, like a temporary fake email, just because, well, I have all my emails signed up here. So what I'm gonna do, Google temp email. There's a bunch of cool services that they give you disposable email. So first link should be fine. Your email, temporary email. Okay, okay, so it's gob79263 at ecofreon.com. Sure, why not? Copy that. And here's my inbox, right? So I can just click copy, paste it here, click on continue. Password. We're not gonna write that password. Let's do 1, 2, 3, 4, 5, 6. It's too short. 7, 8, 9. A, B, C, D. Password's compromised. Okay. Let's do. Okay, let's do this password. Password 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Jesus Christ. Okay, well, I mean, fine. David ate his dog. Really? 99. Thank you. All right, David ate his dog. 99. Save that. Cool. For the record, I shouldn't be doing this, but this is my actual real password. So you can use it if you like, but I have two-factor authentication, so it should be an issue. Anyways, I should probably change it after the stream. Anyways, David ate his dog. 99. Good job, David. Fucking David. Classic David. Okay, continue. Username. It's gonna be VV. Actually, no, VV is my username. What do we do? David ate his dog. That's my username. Save that here for a little bit. Continue. Would you like to receive a podcast? No. Next. Verify your account. Okay, sure. Start a puzzle. Pick a spiral galaxy. This one. Pick a spiral galaxy. Same one. Oh, that was so hard. Oh my god, thank you. I'm intelligent. Who would have thought? Create account. Password cannot include your login. What? Oh, because my username. Oh, Microsoft, please. Why are you trying to make things so obscure? Okay. I'm trying to think of John. John ate his cat. Are you happy? 99. There. Change that password. Continue. No. Continue. Oh my lord. Spider Galaxy. Woo. Spider Galaxy. I think this is Spider Galaxy. Hey, create account. Please work. Please. Okay. Cool. So they sent the verification code. I should get an email in my fake email. 1, 2, 3. I got an email from GitHub. Well, thank you, GitHub. This is my verification code. Thank you. Paste it here. How many members will you be working with? Just me. I'm a teacher. What specific feature are you interested in? No. Fantastic. Yes, the free version. Thank you. I would like not pay any. Oh, dude, that is fucking sick. What the hell? That is actually sick. Watch the session on demand. Okay, I need to watch this. All right, so I created my account, which is cool. Cool. It exists. So now, let me explain some things to you, ladies and gentlemen. I get my tablet out. We go here. Pick a location. This sounds like looks like a nice location. All right, let's talk about Git. How do we use Git? Well, essentially, the first thing you need to do is create something called a repository. So, repo, right? This is your repository. What's a repository? A repository is a box, as all things in programming. Everything is a box in programming. It's a box that contains your actual project. Now, you are free to put whatever you want in this box. You can put one project, so the RPG game. You can put two projects, RPG game and maybe RPG server. Let's say we're developing it for also multiplayer. You can put all your project in all of existence into one repository, right? You can do that. Just repository, just a single box that can contain code. You can put as much code, as much code as you want. You can put different projects if you want. You shouldn't though, but that's what a repository is. Usually, one repository is for one project. We shouldn't have multiple repositories. Sorry, we shouldn't have multiple projects in one repository. Don't add more than one. If you add more than one, that's really, 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 really rush. Really, really, really bad. Okay, just one repository, one project. Now a repository will contain. Okay, thank you. A repository will contain your project, your code, and it will have a name. So for example, I can name this repository. I usually name my repository the same name as my project, but I can name it, for example, cool RPG game, right? So now I can refer to my repository as cool RPG game. Inside this repository, there's a Visual Studio C++ project that's called RPG game, right? And the code is inside here. Cool. Now that I've created the repository, what do I do? Well, when you create a repository, what you could do is, let's say I create a repository, I put my code inside it. After you put your code, you need to stage them. Let me pick a different color. Let's go with red. Stage. What does staging your code means? Well, essentially, when you stage your code, you put them in, you basically prepare them to be saved. They haven't been saved yet. You prepare them to be saved, right? That's what staging means, right? They are in the unstaging area. They go to the staging area, right? Think of it as a performance, right? Let's say you're going to a play. There's the area where all the actors are, or all the people who are gonna play the play or perform in the play. They're like not that area cannot be seen by the audience. That's the unstaging area, or the normal area. And then when they want to start performing, they go to the staging area to kind of start performing. So staging area, just where we want to save our code, but our code is not saved yet. So we put our code, we stage it. After we stage it, we move to the next step, which is committing our code. This is commit. So now when I commit my code, I actually save it. All right, and Git, it will keep track of the code and create a history and a kind of point, a dot in history where that code is saved. Right? So this is my code. It's unstaged. I go and prepare to be. I prepare it and I stage it. Once it has been staged, I commit it with a commit message. So whenever you commit your code, you have to write a message. What did you do today? Right? You can say added first level. Right? So that's my message for that specific code of what I did in that code. Added the first level, and I commit and I save it. So now, if you want to refer back to the code, you can see that the title or the message, you can see your own message, and you can see the date when that happened. Right? And the message is really helpful. So try to be as detailed as humanly possible with your message. What did you do with your code at that day? Right? When you commit it. Don't just say, don't just type a random message. This is actually important. So a year down the line, a few months down the line, if you want to ever go back and figure out what the hell you did with your code, you can just read the message, which is cool. All right, so that's kind of the workflow. So we add our code to the repository, we stage it, we prepare it to be saved. Once we prepare it to be saved, we add a message, a commit message to our code. Once we add the message, we commit our code. Now our code is saved. And if I change my code and then I want to make another save, I stage it. From staging, I add a message, and then I commit my code and I save it there. So now I have 2 commits, right? And whenever we want to save our code, we call it a commit. I made a commit, right? I staged my code and I committed that code into the repository, which is our box that contains our project. So that's kind of the workflow. Now, that currently is only saved on your local machine. What if I want to send it online? Well, there's one more step. It's called push, the pushing step, where I take my code and push it online. It's literally a button I press and it pushes my code online, right? So the workflow: add code, stage the code, commit the code with a commit message, and then push it online. That's it. Now let's say you're working with multiple people on the same project, right? And let's say David right here, he staged the code, he committed something, and he pushed it online, right? And so now you're 1 commit behind. That means your code doesn't have David's code, right? So what you do, before you commit your code, before you stage it, commit it, and pull it, actually, no, that's a lie. So David added his commit, added his own save. So what you do, you take your code, you've written some code here, right? You stage it, you add a message, you commit it, right? But you cannot push it online yet. And the reason you cannot push it online yet, because David has pushed his code online. So now what you need to do is do something called a merge. So I'm merging David's code with my code. So I'm combining both of the code before I push it online. And this merge process happened on my own machine. So for example, David added level 2, right? That's what he did. Okay. And you are adding the first level. So you're working on your code, you add the first level, you stage it, you commit it, right? But you can't push yet. The reason you can't push, because David has already pushed his code, which is level 2. He added level 2, right? So before we push, and even if you try to push, Git will not let you. So what you need to do before you push it online to the cloud, you need to merge your code and David's code together, combine it together. So now level 1 and level 2, I combine them together. Once they've been combined and merged, now I can push the code online. All right, so now that both my code and David's code are pushed online, what if David wants to get level 1, right? What does he do? Well, he will from the online repository, he'll make a pull. A pull is basically him updating the code or taking a pull from the online repository. Now the online repository has level 1 and level 2, right? David only has level 2. On his local machine, David only has level 2. The online cloud has level 1 and level 2. You personally, you have both level 1 and level 2. And the reason you have both level 1 and 2 is because you had to merge David's code. So his changes are on your machine. So you have both level 1 and 2. The cloud has level 1 and 2, but David only has level 2. So now what David needs to do is do a pull and pull the code and save it into his machine, right? If that seems a little bit too complicated, don't worry about it. We'll go through it step by step, and I'll show you what you do essentially. Right? All right. So with that all in mind, let's actually write some code and kind of set up Git. All right. So the first thing I need to do is figure out where. By the way, I updated my project Visual Studio 2020 yesterday. It came out yesterday. Definitely check out Visual Studio 2020. There was a launch event, which I recommend you watch. It's pretty cool. They finally updated Visual Studio to 64-bit. So now Visual Studio is natively 64-bit, so it's much faster, and that's great. Apparently 2019 was 32-bit, and apparently the reason they didn't update it to 64-bit until now is because there were some developers who are still using it in 32-bit. So now they finally pulled the trigger, and Visual Studio is now 64-bit completely. So this is Visual Studio 2022 Community Edition, right? All right, anyways, going back to Git. So the first thing I need to do is figure out where my project is, and I can do it easily. If I right click on main and go to open containing folder, this is my project over here. It exists over here. All right. Now, what I would like to do is close Visual Studio for now. Bye Visual Studio. Do this. Minimize this. All right. Minimize that. Close that. Close that. All right. So, what do I want to do? Well, in order for me to get started, I need to create a repository, right? And we will do that inside the UI, the user interface. We will do the command line. I'll do the command line later. Okay, fine, man. Don't be mad, Fork. We'll do the command line later. I would like to show you the command line. It's useful. It's really important. Sometimes the user interface is just messed up as an issue, or it's way too slow. The command line is super fast. So I'll teach you the command line after I teach you the user interface. Even though it should be the other way around, but I don't want you to sit here. It doesn't matter. We'll do the command line later. Anyways, I need to create a repository, right? So how do I create a repository? Well, you can click on File and init new repository. This is init stands for initialize. So initialize a new repository. And it's going to ask you, where would you like to initialize your repository? Now, you should initialize it in an empty folder, right? So what I'm going to do, this is my RPG game, right? This is my RPG game folder. What I'm going to do is say RPG game old, right? I'm going to create a brand new folder. I'm going to call it all lowercase. I like to have things all lowercase. RPG-game. All right, so this is my RPG game. So I'm going to select that, and I can just open the folder, copy the link up top, paste it in here, and press enter. All right, so I'm going to initialize my repository over here. Now, one thing before you press select folder, one thing that's very important. What I would like you to do is click on view. That if you're on Windows 10, it's similar. You have somewhere view, and you can go to options, right? In Windows 11, it's the three dots and options. There's an option somewhere for the view, so make sure you find it. I don't remember where it is on Windows. You know what? Let's explore. I don't want to leave you in the dark. Let's do Windows 10 view options. So would like to go to images. Thank you very much. Yeah, so here you go, right? So this is a horrible image. Jesus Christ. Could you not have taken a better image? Whatever, it'll do. It's fine. Open this up, please. Thank you. Open this up, please. Thank you. So if you're in Windows 10, the drop-down menu, you see this arrow, right? It'll be pointing down. Click on it so you can get this entire panel. Go to view, and then go to options. Click on options. When you click on options, don't click on the arrow for options. Click on the actual icon options. When you do that, you're going to get this window, and this window is identical for Windows 10 and 11. Go to view over here and select show hidden files, folders, and drives. All right. By default, it's going to say don't show hidden files and folders. So select show hidden file folders and then press OK. Now, the reason I would like you to do that is because here in Git, when I finally select the folder to initialize my repository, and I'm going to click select folder now, it's going to create the .git folder. And if you don't have the option checked out, you won't see this. So by default, here, I'm going to say don't show. I'm going to click apply. You'll see the folder is going to disappear, which it does. So you're not going to see it. But I would like to see it. I like to see things. Seeing things is great, guys, if you don't know that. So I'm going to click on show hidden files. Click apply. Click OK. This is my Git folder. Okay, what is this folder? It's .git. Well, this is here is where Git keeps track of all of your code, all of your save. In this context, the game save, right? If you're doing game saves, all of your code saves are tracked here and they're saved over here, right? So this can get pretty large. If depending on the repository, it can get anywhere between like 100 MB to 200 to 1 GB to 10 GB to 50 GB, depending on whether you're working on a AAA game or not. For one of the games we've been working on for 2 years. It's made in Unity. We commit our code plus the assets, but we do them in different systems. It's around 10 GB, something around that line. The code itself is only like 200 MB, but the assets are like extra, like 10 GB, right? But I digress. So this folder, this actual folder, is where Git keeps track of all your saves, your code saves. So I wouldn't recommend going inside it. I wouldn't recommend playing with it, or doing anything in here. Actually, you shouldn't go here. That's why it's hidden. But I like to see it anyways, right? Sometimes you might need to edit some configuration. You need to do some things, so that's why it's shown. I'd like to have it shown, but usually 99.9999% of the time, you kind of don't want to mess around here and don't want to delete anything, rename anything, or do anything. Just keep it here. All right, so cool. I've created the repository. I initialized the repository, and this is my repository. And this is now what fork looks like. All right, cool. Let's, well, what now? Well, now what I would like to do, the RPG game, which I renamed to old, I would like to open it. We see all of this. I would like to copy all of this. Let's start with .vs. What's the .vs folder? Well, Visual Studio will create a .vs folder, and this folder can get really big, sometimes 5, 6, 7 GB. You can see it's already like 250 MB. Why does it create it? It has some sort of database that it keeps track of things in here. You can delete it, right? It will regenerate it when you open it for the first time or open it again. It will regenerate that folder. So deleting it is completely safe. You should be fine, right? No problems at all. It's just that when you open Visual Studio, it's going to have to index some stuff and keep track of things in the database. But you can delete it. In fact, this is very important. Whenever we're committing code, whenever we're saving code into our repository, there are some files we don't want to save, and one of these files and folders is the .vs folder. We never want to commit our .vs folder because it's auto-generated. It's useless. It doesn't do anything for us. Same thing with our build files. Our build files, like our exe file, this is our game exe, and if I double-click on it, it'll open my project. I never want to commit this code, I never want to commit this exe file or PDB file. And the reason for that is I can just compile it and generate it. These are not important. You shouldn't be committing anything in Git, anything other than code / assets, but mainly code. There's a special thing you do for assets. So for now, keep in mind, you never want to commit in Git anything other than code, text, only text. Git handles text really well. It doesn't handle things like binary files well at all. At all. So we never want to commit binary stuff, or we don't want to commit things that are regenerated on their own or can be compiled, right? So this x64 application, delete it. RPG game, there's an x64 folder here. which has some intermediate files. I'll talk about intermediate files, what they do, why they're kind of there, but we don't need it, delete it. Release is again some intermediate files. This is all auto-generated, delete. Debug, this is also intermediate files that are auto-generated, delete. So this is my code. This is the only things that I would like to commit, my main file and the Visual Studio kind of text files, right? These are actual text files. So if I right click on them and click on edit with Notepad++, this is just a bunch of configuration for Visual Studio. And Visual Studio uses this to kind of figure out what the hell is going on in the project. And all of our configurations, like the things we linked. So remember, we did the solution dependency SFML include. So that this is our include, this is our lib. Our input, remember SFML graphics s/d. All these configurations are just a bunch of text that Visual Studio reads. So these are important. We don't want to delete these because we have to relink everything again. So keep those. Release, empty, delete it. Dependencies, we need our dependencies. Here's the thing though, our dependencies contains two things. Our include files, which are just text files. So if I open this again with Notepad, just a text file. It's our SFML library text file, right? So we need to include those, important. Our libs, however, these are binary files, right? So, well, they're object files. And so I already said you shouldn't commit binary files, but I'm going to make an exception for the lib files. And the reason I do that is because it's easier for someone to just, if you're trying to share this code online, it's easier for them to kind of download the code and have all the dependencies there rather than them having to set up the dependencies. So for these, we're going to commit them in our code. We're going to save them in our repository, but we're going to do it in a special way, right? So just like how we're going to commit or save our assets in a special way, same thing here. So this will go in. We need our dependencies. Debug, it's auto-generated, delete. So essentially, we're left with this. This is all we need. We need the SLN file, which is, again, a text file. That's Visual Studio. This is your project, Visual Studio project, right? This is your actual game code, and these are the dependencies that we kind of need. All right, so I'm going to select everything, Control X to kind of take them, and then cut them. I'm going to go into my RPG game. This is my repository, and then I'm going to do Control V. All right, and here's my stuff. Now, I would like you to keep your eye over here. Specifically, here, local changes. All right. I've added some code into my repository. So now when I click on fork, local changes will update and it's going to show you how many files were added. So let's do that. See, 137 files were added. If I click on it, you will see that these are all in the unstaging area. And we talked about the unstaging area. This is the area where we just put our code in. We never staged them. We never started tracking them, right? So you can see this is all of our include files, a bunch of source files, right? This are all SFML stuff. Our lib files, all of our lib files, and then our actual RPG code, right? So how do I commit this code? Well, I can just click on it and click on stage, and it will move into the staging area. So click stage. It might take a few seconds or a minute, and then see now they're in the staging area. SLN stage, and then RPG game stage. So we staged our code, and now it's ready for commit. Now to commit our code, we need to write a commit message. So first the title. What did I do? Did things. So you can just get away with the title. As long as you have the title, you can click on commit over here. Right? And I highly recommend you do a description too. Be more specific on what you've done. And then when you're done, you can just click on commit. But I'm not going to do that just yet. There are a few things that I would like to do that are really, really important. So I'm going to unstage everything. Right? Keep it unstaged. Right? I would like to add two things. One, a special file called gitignore. So a special file called gitignore. What's gitignore? Well, gitignore is a text file that tells Git what to track and not track. So remember all these folders we deleted? We said we never want to commit them. It would be really tedious. Every time I want to commit, I would have to go and delete everything, right? It would be really tedious. And so let's do that right now. So if I open my Visual Studio project in Visual Studio 2022, right? You will see here, there are a few files that are going to be generated. The VS folder was generated, auto-generated, like I mentioned, all right? And if I go ahead and build my game, so click on build and build solution to build my game, more files will be generated, like our x64 file folder, another x64 folder. So now we have a bunch of things that are here. And if I press play, I should play and see the game, right? All right, it would be, I'm going to close Visual Studio now. It's going to be extremely tedious. Every time I want to commit my code, go and delete the VS folder, delete the x64 folder, and then go in here and delete the x64 folder. And sometimes I might forget, sometimes I miss something. That is really, really bad. So I want to be able to just tell Git to not track these. Simple as that. The way we do that, or to ignore these things, the way we do that is by creating a gitignore file. All right, so now if I go to fork, you'll see that it increased. The files were 133 files, now they're 154 files, because now VS folder exists, which didn't exist before. The x64 folder, you can see, when you see the plus sign, a green icon, plus sign, meaning these guys were just created and they were added. They're going to be added for the first time. If it's yellow, that means this file was added already, but has been modified. Like it was previously added and it's been modified. If you see red, that means this file was deleted. We'll go through all of these later. But right now you see everything is green because we're adding them for the first time. We don't want to add the x64 folder. We don't want to add this x64 folder. I don't want to add this VS folder, right? Okay, so rather than deleting them, we can just tell Git, hey, I want to ignore them. So this gitignore file is kind of, it's different for every language and different for every project. So for JavaScript, if you're doing JavaScript, you're ignoring different files and folder. If you're doing C++, you're ignoring different file and folders, and C# is the same way. So luckily, you don't have to remember any of that or do any of these. So what you could do, just go here, copy gitignore, go to Google, all right, type .gitignore C++. So the file is actually .gitignore. Now, luckily in GitHub, there's a bunch of gitignore files that GitHub provides for you, which is awesome. So if I click on the first link, you can see this is the file. Bunch of gitignore files. All right, this is not super comprehensive. I think there's more, and this is all 2016. This is on the GitHub repository. Is there a more comprehensive one, please? Like a nicer one? Ooh, this is a lot. Oh, this is way too much. We're never gonna have all of these files. Okay, calm down. All right, the first one sounds good. I mean, if we want to add new things, we can add them. All right, so let's look at this code. So the hashtag or pound, the pound means this is a comment. So this is a comment. The star means that all files with the extensions .d. So this is the gitignore folder, right? I'm basically saying ignore all files with the .d extension. So the star means that. Star means ignore all files that end with the extension SLO. All files with LO, all files with O. Ignore all files with OBJ extension, right? And so this is a comment kind of to organize the file. And you can see he's ignoring all files that are DLL files. We talked about DLL files. You don't want to include DLL files because they're binary, but sometimes you might. So we'll handle that case, special case. And he's also ignoring all the lib files, which we really want to include. I would like to include them. Some people don't, but I'm going to include them in kind of a special way again. I definitely don't want to include any of my exe files, right? So what I'm going to do is I'm going to click on raw, right? That will give me just an HTML or just another page that just text. I'm going to select everything, copy it, and in my root folder, I'm going to right click, show more options, new. I'm going to create a new text document, right? This text document is going to be .gitignore. And it's going to say, if you change the file extension, the file might become unusable. Are you sure you want to change it? And I was like, yeah, yes. So now this is a .gitignore. Now, one thing that's very important, going back to the whole option thing. So if I go to, let me delete this for a second. Sorry, let me delete this. I'm going to create my file again. So new text file. You can see now new file.txt. You can see that I have my extension over here. Now, if I click on the three dots, go to options, go back to where I was, there's another option that by default says hide extension for known files. By default, this is selected. So hide extension for known files and hide folder merges conflicts. Those are checked by default. So if I check them, you'll see that now it says new document and there's no extension. There's no .txt. So if I try to change it and I do .gitignore, it's gonna .gitignore.txt. So there's actually .txt at the very end, which tells Windows that this is a text file, which is not what we want. I don't want to have it. I don't want this to have a .txt extension, right? So to fix this, just go to your options again and make sure that you have hide extension for known file types unchecked and hide folder merges conflicts. You don't have to do hide folder merge conflicts, but I do it anyways. Click OK. And now you'll see this now became .gitignore.txt. I don't want to have a txt extension. So I'm just going to delete the txt part. And this file has no name. And the extension of this file is .gitignore. And I press yes. And now it has a .gitignore. Looks like that, right? So that's very important that you do. All right, so I made my file, right? So I'm going to go into Notepad. I'm going to drag this over here. So this is a text file. I'm going to copy all of this and paste them in here. Right, so I've pasted everything in here. Right, I'm going to save it. Control S to save. Right, and again, keep your eye on this number over here. It's now 154. When I go to this software, Git-Fork, it's gonna this is gonna reduce because it's gonna detect that I've added this folder, and it's gonna ignore some files. One of those files is my lib files. It's gonna ignore all my lib files, all my exe files, the SLO files, right? The O files, the OBJ files. So if I click here, now it became 134. There are still some things that it didn't ignore. So for example, it didn't ignore my .vs folder, right? Didn't ignore that. But in dependencies now, if I go to my lib, you can see all my lib files are gone, I want them, I need them, right? But they're gone, which is fine. We'll fix that in a second. But just to show you that this works, right? You can see that all my exe files are gone. There's no exe files. So now, if I go ahead and remove .star.exe and save it, I want you to keep your eye here where it says debug. If I go here, you can see my exe file appeared. If I control Z and I include this and I save it and I go back here, it's gonna disappear, right? So just to prove to you that this file actually works, right? So here I'm saying again, ignore all files that contain files or folders, it doesn't matter, that contain the extension .app or .out or .exe. All right, so let's fix this. The first thing I would like to do is ignore this folder. I don't want the .vs folder. So I'm going to create a section at the bottom with a hash just to keep this organized. I'm going to say Visual Studio. All right, I'm going to do star. That means ignore all files or folders that have the extension .vs. If you don't do star, then it's only going to ignore one file only, or one folder only, which will work in our case because we only have one file, one folder. But the star means everywhere. So if I now notice, this is my VS folder. I saved my code. Look at VS. If I go here, it's going to disappear. You can see now it's gone. Right? I don't have my VS folder anymore. If I remove this, Control S, my VS folder here, add it, Control S, my VS folder is gone. All right, so we're ignoring our VS folder. Nice. That's what we want to do. What else do we want to do? Well, I would like to include ignore my x64 folder. All right, so I can do that now. So I'm going to have another section, compiled, executables, prerequisites. I'm going to have another section here called build, and I would like to ignore the x64 folder. Now, if I just type x64, that will work perfectly fine. First, this is not an extension, right? There's no dot. This is not an extension. It's an actual the folder name. So you can type specific folder or file names that you want to ignore. In my case, in the root folder, you can see that gitignore is in here. And I'm saying that I would like you to ignore this folder because they're both next to each other. I can just type x64 and save it. Again, I'm not doing dot because this is not an extension. If I go here, notice now this is going to disappear, which is cool. What else would I like to ignore? Well, if I expand the RPG game, there is... Oh, that's cool. Okay, so it ignored both x64 folders, the one inside the RPG game, right, and the one outside. Okay? Which is cool. What if I want to ignore the main file, main.cpp? Well, I can do that. I can do main.cpp. You shouldn't, but you can. So main.cpp is if I save it, it's now gone, which is awesome. I don't want it to be gone. I would like to keep it, and there it is. All right, so we're ignoring all x64 files. We're also ignoring all lib files, which is bad. I don't want to ignore lib files. I would like to keep my lib files. I like my lib files. So in here where it says lib, I'm just gonna comment out this line. I can add a comment with the hash. Remember in C++ you do double dash, /. In here I can just add a pound. I can't see my pound. Here's my pound. Save it. Go here. You can see now I have all my lib files, right? Or you can just simply delete the line. Either or works. Doesn't matter. All right. I don't want to delete it. I want to keep it for now. So just keep it. Okay. I would like to keep my lib files. That's okay. My VS folder is gone. My RPG game is still here. Okay. So these are only the files and folders that I would like to commit, right? So this all sounds good. So just to do a quick review, dependencies, they all exist. All of these exist. So let me make sure. 1, 2, 3, 1, 2, 3, and then the main all exist. That's what I want. I want to ignore this. Don't care about this. I want to ignore this altogether. Don't care about this. All right. So these are the only files and folders that I would like to commit into my repository. Okay. One problem though. One tiny, teeny problem. What if in the future you've decided that you want to double click on Visual Studio? Why did you open with 19? Why Visuals? I should have deleted Visual Studio 2019. Why Windows? Why? Okay, so I'm gonna change the extension. So right click, open, properties, change. So this is selecting Windows 2019. We're just gonna do Visual Studio 2020 current. Now it changed. So now if I double click on this, it should open Visual Studio 2020. Fantastic. All right, so one slight thing though. What if I switch to, well, Win32 or x86 and I build this, right? It's not gonna build, I'm gonna get a bunch of errors, but it's gonna create a debug folder, right? And it's gonna create another debug folder. So now if I go here, now I have a debug folder. You can see it's over here. And there's a bunch of files that I don't want to commit. I definitely don't want to commit these files and folders. So what's the solution? Well, I could type here debug, right? I want to ignore all debug folders, save it. Now it's gone, right? But this is a little bit tedious and error prone, and it could cause, you missing something later on down the line. You're always updating that file. So this file. So this is just obvious. You're always going to update this file to add files and folders and things you want to ignore in Git and don't want to get commit. You don't want them to get committed. However, there's a much nicer way, right? First of all, so I'm gonna take a little bit of break from Git and fix my Visual Studio project, because Visual Studio project is fucking stupid. First of all, Visual Studio is creating x64 and debug just in my root directory. It's creating them over here. They're all over the place. I would like to put them all in one location. I would like to have a folder called the build folder. My build folder contains all this trash, all this garbage, and now I can just go ahead and ignore the build folder, right? So all of these guys will be in that build folder, and I can just ignore it rather than just typing it every single time and changing it. And I might miss something, and it's kind of annoying, right? So let's fix Visual Studio before we do any of this, right? Okay, how do we fix Visual Studio? Well, if I right-click on my project, RPG game, right-click on it, go to Properties. All right. Properties, you'll see there's an output directory in general. There's output directory and intermediate directory. Now, here's the thing. Whenever you compile your project, the compilation, the actual exe file and everything that you need will go to the output directory. For the intermediate directory, all of your object files and intermediate build files will go to this path or this location. You might ask and wonder, what in the flying fuck is an intermediate directory? And I have the answer for you, but I'm not going to answer it now. It's just a bunch of files. I can think of it for now. It's just a bunch of files that basically are created when you compile your project. You can think of it that way. They're useless. Well, they're not useless for the compiler. In fact, they're very important for the compiler, but they're useless to you because all you want at the very end of the day is your exe file. That's the only thing you want. So intermediate files are just created when you compile your project. After you compile them, they're fucking useless. We don't need them. All right, cool. So I would like to put both the output directory and the intermediate files inside one location, which is the build folder. And you can see the location is solution dir and configuration, and then here configuration. So these are macros, and we talked about macros before. Okay, before we move any further, make sure you're in all configuration. Make sure you're in all platforms, because we want to do this for all configurations and all platforms. And you see here it says different options because they're different for each one. You know what? I'm just going to do x64 first. I'm just going to worry about x64. So x64 looks like this, and Win32 looks a little bit different, which is goddamn stupid. Visual Studio, what the fuck are you doing? Whatever. So we're going to stick with x64 for now. We're going to fix x64, then fix 32. So I'm going to click on output directory, arrow, edit. Go to macro. Well, first thing, you see that this macro, this is the first macro, this is the second macro, and this is the third macro. And all these three macros will give you this path file. So for example, if I remove the configuration, it's going to remove the word debug. So notice, delete, debug is gone. If I remove platform, x64 will be gone. If I remove their solution, the entire thing is gone. If I just paste configuration, it's only going to do debug. And if I remove the slash removed, right? So these macros, like I mentioned before, they're useful for detecting the correct path of the project. So if you move the project somewhere else, they will dynamically adjust to where the project has been moved. Anyways, I'm going to cancel this because I fucked it up. Going to go and edit again. So this is my directory, right? What I would like to do is after solution directory, which is just this part, right? RPG game, which is this path, RPG game, I would like to create a build folder. Inside the build folder, I'm going to do a slash, paste all of this. So x64 and debug, right? Now, in build, I want to add one more file. I'm going to go bin slash. So the path now is solution dir build dash bin. Bin stands for binary. So I want all my binary stuff, my exe file, to be in this location. All right. So binary x64 binary. So let me think about this for a second. So just copy this. Go here. Whoops. Sorry. Go here. All right. So this is the path for what I want for my binary. For my intermediate file, I'll do intermediate, right? So build intermediate, and then x64 debug. I don't like that solution. I think x64 dash debug dash bin. I think this is nicer, right? It doesn't matter how you do it. I'm gonna do it this way. You can do it differently. It doesn't matter. But the reason I do it this way is because when you build, you want to go to 32 or 86. Or sorry, 32 or 64. Once you go there, you want to go to either go release or debug. And then you want to go to either intermediate, which almost you never go there, or bin, which I want to go. And inside bin, you'll have your exe file, right? So these two are much, much nicer than this. The reason they're much nicer is because build, you go to bin. Inside bin, you have to pick the platform 32 or 64. When you go there, you pick debug or release. When you go debug or release, you see your exe. It's just different organization thing. You can select whatever one you like. I'm gonna go with this one. I like this one. All right, so this is the plan. So how can we do the plan? How can we do this? Well, RPG game, it's this part, right? So we got that covered. So that's my RPG game. I need the build part. So the build part is there. Okay. So we got the build. Next, I need the configuration. So rather than bin, I want to move the configuration. Sorry, not the configuration, platform. I want to move the platform before bin. Right? So it's like this. So build x64, build x64 slash not bin. I'll do configuration before bin. So do that. And there you go. So now it's the RPG game build x64 debug bin. It's fantastic. So this is what I want. So I'm going to copy this. I'm going to paste it here. I'm going to copy it and paste it again. And instead of bin, I'm going to change this to intermediate. All right. So this is the macro. This is the actual macro I'm going to paste in Visual Studio. This is just for me so I can visualize it and make sure it's actually correct. So build x64 debug bin. All right. That's okay. Now let's do the intermediate part. Now actually I don't need to do the intermediate part. I can just jump into all configuration, all platform, because now I figured out the macro that I want, the exact macro that I want. The difference between x64 and 32 is now in the configuration. This is gonna say win32, something like that. So let's figure that out. I'm gonna, just as an example, as a test, I'm gonna go to win32, click on no, I don't care. All right, go here. And then I'm gonna copy this macro, this exact macro, and see what happens. So this macro, see, it says win32, where before it said x64. So the macro adjusts depending on the platform, whether x86 or 64. The macro will also adjust whether you debug and release. So if I click on OK, damn it, I pressed cancel. Whoops. So I'm gonna go Win32 and select release, for example, right? So if I paste the macro over here, right now it's Win32. Notice before it was x64 debug, now it's Win32 release. So the macro, again, the macro adjusts, which is super, super cool. But I'm gonna say all configuration, all platforms. I'm gonna delete this garbage. I'm gonna delete this garbage. Make sure both deleted. Output, I'm gonna use this macro. Right, this is my macro for the output directory. I'm gonna use this macro, which is gonna be d win32 build win32 debug and bin. And win32 will adjust depending on the platform. Debug and release will adjust on the platform. This is static. It's the word bin, and build is static, which is what I want, which is okay. So now I'm gonna copy the intermediate one. Gonna do the same. Click here, edit, paste it, and click apply. All right, cool. Just to test it and just show you it works, I'm gonna click on here. This is Win32 debug. If I switch to x64, it should say x64 debug. If I switch to release, it should say x64 release. So it's always adjusting, right? I'm gonna keep it on platform, all configuration, all platform. Press OK. I just adjusted everything. This is all what I want. So this is perfect. So now, moment of truth. Delete the debug folder. Delete the x64 folder. Delete this garbage folder. These two garbage folders, right? Just I have my code in here. I just have these guys here, and I have my dependencies. Now, moment of truth. I'm gonna switch to x64 debug. Right click on the solution. Click on rebuild. Look at that. It created a build folder for me. Inside the build folder, my configuration, which is x64. Inside, I have my debug, which is here. Sorry, platform, and then, this is my platform. This is my configuration, and I have bin or intermediate. Inside bin, I have my exe file. My intermediate files are in my intermediate files, which are useless to me, but they're important to Visual Studio. Well, while compiling, but now I can just delete them, doesn't matter, right? There, this is much, much more organized. And this is so freaking cool, because now if I go here, right, and I go back to my gitignore file, now I can delete those two, right? And I still have, look here, the build folder, build x64. I still have all this garbage. Now I just say ignore the build folder. I'm just gonna ignore the build folder. That is awesome. That is so cool. Organization is cool. So there you go. That's it. That's all I wanted to do. So now, even if I switch my platform, let's assume I do release and 32-bit for whatever reason, I'm gonna click on build. I'm gonna get an error, but in build now you'll see Win32 x64. Win32 will have release, and in release I'm gonna have bin intermediate. Bin is not gonna have anything because it failed to compile. Intermediate will have some stuff, right? But this is not gonna be in my project, and forget, it's gonna be ignored because I said, hey, ignore my build. So here, there's nothing. There's only my SFML, which is my include and lib, and it doesn't exist. Isn't that cool? It's really cool. Super cool. All right, we have our project configured. That's nice. We're saying, hey, yo, bro, ignore my VS file. My VS folder, and ignore my build folder. Two things I would like to ignore. Keep everything else. So I commented this line, so this line, I might as well delete it, honestly. I'm just gonna delete it. DLL, I like to have my DLL files. They're important. If I have a dynamic library, I want to keep them, so delete this. dlib, this is dlib for, I believe this is for Linux. I would like to keep them. This is for SO, is for Mac. Wait, no, dlib is for Mac, SO for Linux. So I might as well just delete all this. I wanna, these libraries, so my DLL, I want to keep them. These libraries, all these library files, I want them. Just because if someone wants to use my project, I'm gonna make this publicly available, by the way. So if someone wants to use it, they have all the libraries they want. They don't have to get them from somewhere else. So I'll just keep them over here. Okay. PCH, ignore that. Yeah, ignore all of this. DSLO, all this garbage. Ignore my XE definitely. But it doesn't matter because I'm ignoring the build folder altogether. But just keep it, whatever. And there you go. I'm ignoring all the things that I would like to ignore. So I'm gonna just wait a second so you can see the code in case you need to copy it. Doesn't matter. You'll see the code. You'll actually have access to the code if you need it. All right. So this exists, which is fantastic. So now I have git ignore setup. I have my Visual Studio configured correctly. I'm gonna close Visual Studio here. Visual Studio is configured correctly. My dependencies are fine. One thing I would like to do now, just the last thing before we commit our code finally. These guys, the lib files, they're binary. They're not text. And I said that whenever you're doing this, for the love of God, your code should be, you should only commit text files, nothing else. For binary files and images and assets for the game, we're going to commit them by using a special system. System is called Git-LFS. All right. Holy shit, we're an hour and a half in and there's still so much to do. All right. So what's Git-LFS? Well, if I type Git-LFS, you'll see that Git-LFS stands for Git Large File Storage. So what does this do? Well, if you read here, large file versioning, version large files, even those are large as a couple of gigabytes in size with Git, more repository space, host more in your repository, Git repository, external file storage, make it easy to keep your repository at manageable size, faster cloning, and so on and so forth. Right? Essentially, Git-LFS is an extension of Git that allows you to commit big files and binary files. And so, why do we need this? Well, here's the issue. Here's the issue. The issue is that I would like to introduce you to the concept of cloning a repository. What does it mean to clone a repository? Okay, so you're working alone, right? This is you here. You're working alone. You're committing your code. You're pushing it online. David doesn't exist yet, right? He wasn't born, right? He doesn't exist yet. You're working all alone as a developer, right? Let's say you hired a guy to as a team member. Let's call him David. Or even fuck that, forget that. Let's say you want to have this code on your laptop. Right now it's on your desktop, but you would like to have it on your laptop, right? So what you do, rather than copying the code from your desktop to your laptop using a USB flash drive or USB storage drive or whatever you call it, right? Those tiny sticks that have storage for 256. I call them a flash drive. I think they're called flash drive. Whatever. Rather than copying to a flash drive or an external hard drive and then pasting them in your laptop, what you could do, your code is already on the cloud. So what you could do on your laptop, clone your project from the cloud. Okay? What is cloning? What does it mean to clone something? Cloning essentially means that you are downloading your code from the cloud into your own machine, right? Rather than copying it from one computer to the other, you just can download it or clone it from the cloud. Okay, that's great. What does that have to do with LFS? Well, here's the thing. If you commit your PNG files, if you commit your PSD files, Photoshop files, if you commit really large files, let's say you have a PNG file that's 1 GB, storage. That's how big it is. It's 1 GB, right? And you committed this file into your repository, and you've had multiple of them. Let's say there's 10 of them. That means now your project is 10 GB plus whatever your code size is. And your code is doesn't go, even if you have thousands and thousands of lines of code, it probably doesn't go above 100 MB or like 500 MB maximum. Like, I think the Unreal Engine repository, the entire Unreal Engine repository is not bigger than 1 GB. And there's 40 million lines of code, I think, when I calculated it. I think there's 40 million lines of code. I could be wrong. I could check. But that was like 500 or 1 GB. Because it's only had code, right? The really thing that Git struggle with are large files, or large individual files. Your text file, you have 40 million small files that are not bigger than 10 MB. So each single file, each single source file is like maybe 5 MB or 3 MB or 200 KB. Git handles these fantastically well. No issues, no problem. But when it comes to large files, large single files that are 1 GB alone, one file that's 1 GB, Git is going to struggle with it a lot. Okay, so now we use LFS to store these large files, these large single files. And the rule is, if a single file is bigger than 100 MB, you should commit it into Git-LFS. Right? That's the rule for GitHub. I don't think GitHub will allow you to commit more than 100 MB per file, right? Or is it 10 MB? Something along these lines, right? But the rule that I use, if it's a binary file, if it's binary, if it's assets are binary files are also assets files, images, audio files. Any assets for your game, anything, literally, anything other than source code, anything other than text and source code should be committed into Git. Anything else should use LFS. Right. So LFS is a sub-file system or subsystem in Git that will handle binary assets, audio, images, movies, all these things really well. Okay, but let's assume you're not using LFS. Let's say you're not doing that. What happens when you clone the project when you clone your project? What happens? Well, it's gonna take a while to clone. It's gonna take anywhere between, depending on even if you have 1 gigabytes, if you have 1 gigabits per second, 1 gigabit, 1 Gbps. ITPS. Even if you have 1 gigabits per second, that means you're downloading at 100 MB per second. That's a really fast internet connection. Even if you have that, you're gonna struggle cloning this. And the reason you're gonna struggle cloning it, and let's say your repository is only 10 GB, your project is only 10 GB, is because while you're cloning, at some point, maybe 50% along the way, or 60% along the way, or 20% along the way, or 90% along the way, you are gonna get disconnected from the server. By default, you're gonna get timed out. Time out. When you get timed out, that basically means you got disconnected, or the server was like, fuck you, you've been connected to me for a really long time, fuck off. You have to restart the entire process. And there is no way in hell that you're not gonna get timed out. So basically, you are literally unable to clone your repository. And that's a problem. Now your project is just stuck in the cloud. There are ways to do it, but they're drastic measures that you shouldn't even do them in the first place. Okay? So that's why we shouldn't commit large code. We shouldn't commit large files here. We shouldn't commit large files into our project. We should use LFS. So with LFS, the way this happens is, here's your Git repository. So Git is over here. Here's your source code. Your source code is nice. It's all there. You clone it. I'm cloning my source code. It's like 500, let's say 50 MB. Right? You have a really big game. Let's say like a really big game. It's 150 MB. You clone it, it's cloned in your project. That's fantastic. It works fantastically now. Great. Next, after you clone all your source code, Git-LFS will trigger. So LFS will trigger and download all of your assets like audio, graphics, any large single files, it'll be downloaded. So now, with LFS, you're not going to get timed out. The server is not going to kick you out, right? But so the server is not going to kick you out, right? Which is great. So that's why we kind of want to use LFS. All right. So with that in mind, source code, text is committed normally into Git. Any large assets, any large single source files, audio, movies, graphics, anything other than text should go into LFS. All right. So what does that have to do with our lib files? Our lib files .lib are actual binary files, right? Binary. They're binary files. And so these binary files needs to be committed into LFS, which is the whole point. That's what I want to do. All binary files or DLL files will go, all .png files, which will set that up, all MP4 files, MP4, MP3, WAV files, all these guys will go into LFS, and we're going to configure LFS to do that for us. All right? That's the idea. And it's really important you set up LFS. Otherwise, things are not going to go very well for you. All right, cool. Let's do this. How do we set up LFS? Well, so if you go to LFS, it's going to ask you to download it, but thankfully you don't have to do it because LFS comes bundled with Git-Fork, and it's already bundled with Git, I believe, if I'm not mistaken. To verify that you have LFS, what you do is go to repository, go to settings for this repository. That's wrong, sorry. Go to file, preferences, go to Git, and you will see that you have Git-Fork instance. It used to show it here. Well, I guess it doesn't show it here anymore. It doesn't matter. If you go to repository, sorry. If you go to repository, here we go. Git-LFS. So Git-LFS already exists. Or it already exists with fork. It doesn't exist in your repository currently. It's not there in your repository, but it exists inside fork. So we need to initialize LFS. Easy. Go to repository, LFS, initialize LFS. Now it's initializing LFS. And now if you go back, you'll see that you can add a track pattern, a fetch, pull, pern, and a bunch, and de-initialize LFS. All right. Now, when you initialize LFS for the first time, you've initialized it. It's great. It works. It's fantastic. Let's add some things. So I'm going to go to repository, git LFS. I'm going to go add track pattern. What do I want to add? Well, I want to add all .lib files. And you will see all of these files. This is a preview. All of these files will be included in LFS. So these are all my lib files, which is fantastic. .lib. What else do I want to add? I want to add all of .pdb. So all PDB files will be added. Here's the problem. When you also do that, it will add PDB files from the build folder, which I don't want to do. So we're not going to do PDB. Instead, what I am going to do is I'm just going to specify a certain directory, right? And the certain directory that I want to specify is dependencies, SFML, lib. Right, so I'm gonna just track this entire location. So I'm gonna copy from dependency SFML lib, copy that. So now in theory, and do a slash. In theory, I should see the PDB file, which I do not. Right, maybe slash over here. No, dot slash. No, dot slash like that. No. Move that. There you go. Okay. So dependencies the other way around. So make sure it's not this slash. It's the slash. Linux and Windows. So Windows loves the slash. Windows loves this, right? Windows works with this. The entire universe uses this. So Windows is just fucking stupid. So just use the slash. So now you will see that now we're including not only lib files, but we're also including PDB files. What are PDB files? They're useful for debugging. They're very useful for debugging, so we want them, and I'll cover them in more detail later on. So even if you deleted this line, all libs, you will still have everything, because I'm basically saying I would like to track all of the dependencies in SFML folder in the lib folder. So track everything inside here, right? But I'm also gonna do lib, right? Because in case there's a library folder somewhere that's not in dependencies, which is very rare because all of our dependencies are gonna be there. So technically, I really don't need this, right? My reasoning was, what if there's a library folder or library file outside my dependencies? So what am I? It should be tracked, right? But realistically, if you didn't fuck up everything, all the lib files should be in dependencies. So I want to track all of this. What else do I want to track? Well, in my project, I'm going to have an assets folder. So I'm going to create a folder here, right? Call it assets. And in fact, this assets is going to be inside RPG game over here, right? So this is my assets folder. So I would like to include, but no, that's not going to work because this assets folder will be copied somewhere else. Either way, I would like to include this assets folder. So the way I do this, again, just copy this slash assets, right? So everything in this assets folder will be included, right? Let's say I include an image. So let's make an image here. Let me go to Paint, draw a guy. Hi, ha ha ha! Look at me, I'm so funny. Save it. I don't know what that was. Don't ask me. I'm sorry. Copy this, paste it over here, right? And click. I'm just gonna call it face. It's not a face. It's a human. Oh, whatever. It's face. Save. Now, in theory, I should see face somewhere in here. Face. 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 Hello. Hello. Oh, slash. Sorry, forgot the slash. Don't forget the slash. Face. Here you go. So RPG assets face, right? PNG. So it included all my assets are going to be here. My PNG files, my JPEG files, my audio files, and everything is going to be here. So those are the two folders that I want to keep track of, right? That's really important. What else do I want to keep track of? Well, just in case, for whatever reason, there are some files like image files, audio files that are not inside assets for whatever reason. I also want to make sure that Git-LFS keeps track of them. So I'm just going to I'm going to do the same thing for lib. So all the files, for example, let's say they're not in dependencies for whatever reason, I want to keep track of them. So I want to do this at the top. So I want to do lib. I want to do .png. What are the most common ones? .jpg. And instead of writing this entire list, luckily, there's a list that already exists for you. So if you go to Google, right, rather than remembering all the extensions, if you go to Google and type Git-LFS assets list, right? And then I'm gonna type Unity. The reason I type Unity is because the Unity one is very comprehensive and a lot of it applies to us in SFML. So the first link, you can see there's quite a collection here, right? So if I copy this, I'm just gonna copy them into like just somewhere else, right? I don't need any of these. These are Unity specific things. But what I would like to have is JPG, all of these, GIF, PSD, AI, MP3, WAV, and OGG. This is not the most comprehensive list. There's still some more, like audio stuff. So audio, video. We could have a video playing. 3D model stuff. We're not doing 3D models, so we don't need this. DLL stuff. No, I don't want to include any of that. Okay, so nothing here. Wait, I want to include DLLs. Oh, I forgot to do DLL. Okay, so let's do DLL. What do I need? I need DLL. So this line. You know what? I'll include etc. All this etc. etc. Okay. So do that. I don't know what's an A file. EXR. We're never gonna use EXR. TGA. I keep it. This is an image format. PDF. Never PDF. Zip. Sure. I think we'll have one. A DLL. Sure. Unity package. Only Unity. I don't think we're using TTF. That's fine. RNS. No idea what that is. No idea what that is. No idea what that is. Okay. So these are kind of the most common ones. And if you go more, you can find a more comprehensive list than this. So all of this. All of that. There's one that's super comprehensive. It has a lot of things. All right, here we go. So you can see so many more, like so many more file formats. So we're just gonna copy all of this, paste them here, and just see the difference. That GIF already exists. Delete this line. HDR. We're not gonna have HDR. We're not gonna have IFF. JPEG. Delete this line. Already exists. This line already exists. Pic, sure. PNG, as you can see, PNG already exists. Delete it. PSD already exists. TGA already exists at the bottom. Actually, I'm gonna delete it from here. Diff. There's two diffs. Sure, whatever. Okay, so all of these are unique. Fonts. I will have fonts. Definitely, we're gonna have fonts. So add the font section. Audio. This is, I believe, this is a lot more comprehensive than, yeah, definitely, than what we already have. MP3, we already have it, so delete this line. Wave, we already have it, delete this line. OGG, we already have it, delete this line. Oh, is AIF and AIFF are, oh, this is different. Okay, never mind. IT mod, okay, so these are a bunch of audio stuff. Yeah, that's it, I think. I mean, we can keep looking to have even a more comprehensive list. Do I have PSD? PSD, and AI. So this is Photoshop and this is Illustrator, Adobe Illustrator. I think this is a pretty comprehensive list. If we ever need to add more things, we can add them later. Okay, so here is what I am going to do. I am just going to add these two files. I'm only going to track these, right? And then click on track. Now, before I click on track, you'll see, notice, a new file will be created here that's called Git attributes, right? So notice here, I'm gonna put this a little bit right. Track, Git attribute, and there you go, Git attribute. If I open up Git attribute, you will see that it included these two lines, right? And LFS does this. So it includes the path and then says filter equal LFS, diff equal LFS, merge LFS, and text. Okay, so what I'm going to do, this list that I've created, I'm going to copy this entire list, make it a little bit nicer, first of all. So spaces here, just make it a little bit nicer. I love organizing things, and so should you. All right, and then I'm just gonna have one last section. So this is etc, right? I'm gonna copy this. Now I would like to do lib, copy and paste. I would like to do DLL. All right. Now you might wonder and say /text. Why does this say /text? These are binary files. The answer to that question is I don't fucking know. All right, this is my extent of the knowledge, is that you just copy this and it works, and as far as I know. Actually, DLL is there twice, so delete it from here. Just want to add my lib and DLL, and this is a pretty comprehensive list. I can just delete this and Control A, Control C, close this, and then I put them at the top. So I usually put all my extensions at the top, and any specific directories I put them at the bottom. So this is a pretty comprehensive list. So save all of this, and again, the star means it's gonna commit all of the zip files. All right, now how do I verify that all of this works? Well, do you see here? It says LFS. Whenever you click on it and it says LFS, that means LFS is tracking this. So all my lib files are being tracked by LFS. PDB files are not being tracked by LFS. Why? If I go to face is being tracked by LFS. Why is PDB not tracking LFS? That is odd. It should. Because I literally said track this folder. Okay, hold on. What if I remove this line? So this is my lib. I'm gonna comment it out. Save it. Go here. It's not. At least it doesn't. It says it's. At least it's not giving me the icon that says it's tracking it. Is it tracking it? I have no idea. So let me go to add track pattern. Will it give me something? No. Maybe I go Git-LFS. No. Oh. We might have to use the command line for this one, boys and girls. But it should, like in theory, it should. So, okay. So just to make sure, I'm gonna cut this, save it, save all of this. I'm gonna go here, add track pattern, paste these guys, and just paste the directory like this. So now it should be doing it, and then say track. All right, it's gonna tell me to reload the folder. It reloaded it. If I go back here, still this is not being tracked. Lib files are being tracked because I uncommented this. That's odd. I don't know why that's happening. It says faces being tracked, but again, the only reason faces being tracked is because I have PNG here. So if I remove PNG, it will say it's untracked, even though it should be tracked. I mean, in theory, it should be tracked, unless I'm doing something really wrong or it's doing something wrong. Okay, so I think there's another way to verify what's being tracked or not. So I'm just gonna stage everything. All right, stage everything. Click on the, yeah. All right, so there's another way to do it. I think it's in the command line. So I'm gonna go back to organizing this a little bit more. So in the command line, I think there's a command you type that you make sure that what's being tracked, what's not being tracked. So you don't rely on this too much. All right, so what I'm gonna do, I have to Google this. I don't remember the command line. So here we're gonna do list files tracked by Git-LFS. Open. All right, so let's see. So Git-LFS ls file /all -all. All right, so I'm going to copy this command. Right now, to make this work, I mean, this is kind of a perfect opportunity to go and use our terminal, or kind of talk to you about our terminal. All right, let's kind of introduce you to this. ls is for list, so you list everything, and ls works on Mac and Linux. On Windows, it doesn't work, but because this terminal is kind of a Linux terminal, ls works. If you use the command prompt, right, and type ls, it's gonna tell you, I don't know what the fuck ls is. So for the command prompt, you do dir. Dir stands for directory, so list the directory. Okay, but we're not using the command the command prompt, we're using this, so ls works fine. Clear clears the screen. ls lists my files, right? So if I do cd, that means change directory. Let's say I want to go one directory back. So cd dash dash dot dot dash. So that's going to go one directory back, one folder back. Press enter. This is my desktop. I don't think I can go back any more than this. So clear. What I want to do is go to this location. Now I can go to this location one of two ways. Either right click or select this, copy it, and do cd change directory, right click and paste, and press enter. That will change my directory, right? Now I'm in that location. And notice now, this says master. Whenever this says master, this is my branch. We didn't talk about branches, so this is related to Git. So that means I know I'm in Git 100%, right? But cd, that changes the directory. If I don't do it the lazy way, which is, well, it's not the lazy way, it's the fast way. If I want to tap it out, I'm going to do cd C. So I'm just going to go to my C drive, right? ls to see all my files, right? I can do cd users to go to the users folder and then press enter. Now I'm in C users. ls to list all my files, and I want to go to conta. Conta is my folder, my username. So cd change directory conta, and that will take me there. ls, they'll show me my download folder, my video folder, my documents, app folder, and so on and so forth. So that's how you can navigate. So if I want to go, I want to actually go here. So I'm gonna do cd and go to the D drive, cdd. And then you can see I'm now in the D drive. ls, these are my folders. I would like to go to RPG game. So here's the really cool thing. If you don't want to type the entire thing, rather than typing cd rpg-game, what you could do is say cd rp and then press the tab key on your keyboard. Tab, it'll autocomplete. Now it'll autocomplete only because I mean, if you should press tab again, it gives you the options. There's a file that's called RPG game. There's a file that's called RPG old and RPG game, right? By default, it just gave me RPG game, which is kind of cool. So you can autocomplete stuff. If you just press R, it can't, well, it's going to autocomplete that. And if you press tab again, it's going to give you a bunch of options here, what you want, right? Which is kind of cool. So RPG, autocomplete, press enter. Now I'm here, clear it, clear everything. Now I'm going to paste my command. To paste my command, that was here. I'd like to paste this, please. And press enter. All right, so this, in theory, it's listing all the files that are being tracked by LFS. And right now, face is being tracked, all the lib files are being tracked, and that's it. Well, this is fucking annoying. Even the command line is like is on the same page as this. So for whatever reason, the actual directory, at least it appears that it's not being tracked. I have no idea if it's being tracked or not. It looks like it's not being tracked. Not LFS. So here it says not LFS. I don't know why it's doing that. I have no idea. So just to stick on the safe side, right, I'm gonna remove this whole idea of, just gonna edit this. I'm gonna remove those two lines. So we're gonna remove the whole, or if I just do this, if I think it's gonna be pissed off. I don't think that'll change. Let's do this. Yeah, that didn't do anything. Whatever. So I'm just gonna delete those two lines. We're not gonna track a specific directory. For whatever reason, that's not working. I don't know why. It's a bug or something I'm missing. But in this case, I'm just gonna include like the PDB itself. So I'm gonna copy this PDB. Let's command. You should be able to see. Oh, I need to stage everything. Hold on. So first you have to stage this. Don't forget to stage it. Then run the command again. And what in the flying fuck? Why are you being an asshole, man? Okay, let's go here. Is PDB being unstage? Stage. Do I have to unstage everything? PDB. I have to unstage everything. Oh my god. Okay, you're kind of funny. You're actually trying. You're actually starting to get on my nerve. Okay, so you have to unstage everything, unstage them, and then you have to stage everything again, right? You can see if I click on this PDB, it's now in LFS, and I can verify this from the command line. So if I click on clear, so clear everything, and I'm gonna press the up key. If I press the up key, you get commands that you've used previously, right? So if I click on Git-LFS, I should see everything here that I've tracked. I tracked my lib files, my PDB files. Hey, Ducky Dev. Um, don't worry, man. I mean, hopefully just give it a few months to a year and you'll get there. Anyways, all right. So now I verified that PNG files are being tracked, lib files are being, so all these files are being tracked, which is good. So to mention this again, these are the extensions that I'm tracking in Git-LFS, the actual extensions, and for whatever reason, folders tracking specific folders are not working. So yeah, we're gonna kind of ignore that. So now we're just tracking things manually, right? The actual extensions rather than the directory, and this works fine. All right, so I can close this. I don't need this anymore, right? Okay, so here's the thing. I've set up everything. Yeah, so let's go back, unstage everything. Right? I've set up everything. I've set up the two most important things. My gitignore that ignores files I don't want to commit. These are the files that I don't want to commit. My git attribute are the files that I would like to commit into LFS. So my repository doesn't get unbelievably big and I can't clone it anymore. Right? So now that I've set up these two, and I only need to set them once ever. Like if you ever create another project, another SFML project, you can just copy these two files and paste them, right? You don't have to do, like, the first time is always the hardest. And the only reason I'm doing this the first time is because, well, I'm showing you how to do it. Otherwise, I already have these two files in my other projects, so I can just copy them and paste them all around, whatever I want them, right? But anyways, I set up these two files, the most important part, right? And now, just to verify everything is being tracked correctly, if I click on my lib, it's tracked by LFS. If I click on my PDB, tracked by LFS. Face is being. I need to delete this. Face is being tracked, so I should need to delete this. I don't actually need this to be committed. So there you go. Right. So there you go. Everything is being tracked correctly. Right. All my lib files are being tracked by LFS. All the source code are being tracked by normal Git. So now, select here, click Shift, select everything, stage all of this. All right, and let's actually write a commit message. So my commit message would be, so the title would be setup SFML. And one of the things that I did, if I double click on my project, what did I do here? If I go to my project, it's pissed off because I need to be in 64-bit mode. I created the circle, so let's type that in. Added circle shape. Added or setup SFML window and main game loop. Added circle, added rectangle. That's all we did so far, right? There you go. Okay, so I got all that set up. I put my messages, more detail, description. I put my title. Now I can commit. So staging, I'm preparing them to be saved. Commit, I am now going to actually commit them. Now, one last thing. Before I click on commit, notice at the top, it says the attached head. This is currently not in a branch. Okay? So I need to unstage everything. Apologies, I forgot to do the branch thing. Now, let me explain what a branch is. A branch, okay? So in Git, we have something called branches, and a branch is a box. All right, so let's take this from the very top. I have my repository over here. So this is my repo. This is my repository, and here is my branch. This is branch number 1. This is branch number 2. This is branch number 3. This is branch number 4. I can have as many branches as I want, but now right now I'm just gonna create 4 branches. What are these 4 branches? Well, one is gonna be called master. It's either called master or it's called main. I'm gonna stick with master because that's the most common one, I think. Master branch. Next, the second branch is the dev branch. And you can name these branches, by the way. You can give each branch a name. I'm naming them right now. I'm creating them right now. So I have dev, I have master, I have build, and I have master, dev, build, and what can I make? Let's do stage. The staging branch. Okay, so I've created a bunch of branches, right? What do these branches mean? Okay, a branch, so this is your larger repository. A repository has multiple branches, or you can have as many branches as you want, or even one branch. But you need to have at least one branch. What's a branch? A branch is a box that organizes or categorizes your code. So for example, in my current workflow, I am saying that there is a master branch. The master branch usually will have commits. So all of these will have commits. Double M or single M? I'm gonna do double M. I think it's double M. Is it double M? It's double M. Look at me spelling. I'm so good. All right, commits, right? This is the master branch, and it's gonna have like 1, 2, 3, 4, 5 commits. It's gonna have 5 different commits. Each single commit is a save in point of your code. So this is one save for your code, one save, right? And each commit is different feature. So for example, in this commit, I said added main character. So this is my main player. Another commit that says added animation. So I added animation over here. The second commit. The third commit I did added audio. Right? The fourth commit I said add physics. This should be added physics, right? Added audio, added animation, added main character. So 1, 2, 3, 4. One last commit. What else do we have in the game? Added multiplayer. Now these are really large. Like this is a large thing. Usually you don't say added main character or added multiplayer. There are a lot of steps in adding multiplayer code. So, but for this example, it's fine, right? So a single branch, one branch, can have multiple commits, right? Another branch could have either the same commits or different commits. And another branch will have either the same commits or different commits. Okay, so why do we have branches? What's the point of branches? Well, think of this game as an actual software that you're developing that you want to release and sell to your actual customers. Right? So I'm making a game. I'd like to sell it to my main customers. So myself, I always work in the dev branch. The dev branch is the most unstable branch. This branch will have buggy code, code that doesn't work, code that's broken, code that I could, for example, I could write some code, commit my code into the development branch, and I go to bed, and this code is broken. It doesn't work whatsoever. But I'm tired. I want to fucking go to sleep. So I commit it into the dev branch, right? That's unstable code. So usually I name my branches dev, and I commit my code in unstable, in an unstable state. They're in dev. They could be stable, they could be unstable, they could have bugs, they couldn't have bugs. This is basically my day-to-day commits. I commit all my stuff day-to-day in here, in this branch. And so this branch will have a bunch of commits and a bunch of save points for my code. All right, so that's cool. Now, after working on the game for a year, I would like to build my game for the public, like an alpha test. So what I do is I merge this branch with this branch, meaning all the commits that's inside the build, dev, I kind of copy them, or, well, kind of copy them. Not copy them really, but I kind of, let's say copy. I copy them into build. So that means both dev and both build have the same commits now. But now I know, after working on this for a year, my code is stable enough to put my code in the build branch. And so the idea here is that for the dev branch, I'm adding all my code that's unstable. I added like 10 commits. Once my code is stable and I would like to build it for the public, I take this code and I put it here. And the final commit, which is the same final commit here, the final commit is finally stable code. This is the final commit, which is going to be the same commit here. Stable code. All right. So now, later on, I can switch back. So this is my build, right? And now, if the public or if someone takes my code, or if my teammate wants to test out the game, all they have to do is go to this branch and execute the last commit, which is in this case stable code. So this is stable and it's buildable. Now I want to add more features. So this was the alpha, for example, one of the versions of the game. And now I switch back, me as a developer, I go back to my development branch and I add more commits. Right now, code is broken, buggy, not working, not stable. Right? This is my own branch. I develop stuff in here. When I commit stuff in dev, they're not going to be committed in build. They're not related anymore. Right? They're not the same. The last commit that I put here was the stable code, and here I'm doing the unstable stuff. All right, cool. Now, if someone wants to go build my game, they can just go to build. And if someone wants to see the latest features, they might be a little bit broken, they can go to dev. So dev has more commits. Build has less commits, but it's only has the code that's stable. Or the latest commit is the one that's stable. Now, finally in development, now I want to release my beta. My beta, I added so many more features, and I hear stable beta code. I finally have my stable beta code. So now what I do, I merge the development branch inside build. And merging, meaning I'll copy, well, again, not copy, but I will take all this code and move it in here. Well, not move it, but let's go with copy. It makes a lot more sense with the copy. So I copy all these commits and put them here, the exact same commits. These are identical. So now these are the same, the exact same branches. There's no difference now. Stable beta code, right? And now I can, this is the stable branch, and I'm doing work on, I built this game on the stable branch and everything is work. Now I would like to add more code and polish the game. So I switch back, now I'm in development. I'm currently here. So I go and kind of do more work. I break the game. It doesn't matter if I break the game because I know that this branch has this commit, which now this commit has the latest stable build, which the user can use. right? Or not the user. Anyone can just go hop in and check out the build, right? So a branch is just a way to organize your code. There are some commits that exist here that don't exist here, and if I want them to exist in both places, I merge them, meaning just copy the commits and paste them in here, and they will have the same. They're now identical. But then then I can switch back here and I can do more work, and now they're not identical, right? Again, the idea here is that for this branch, the build branch, it's gonna have a stable game that can run. And if I wanna do some more work on my dev, I can. Now this might be a lot of information and you might not have understand this completely quite well. This is fine. We're gonna go through this entire process every single day, and you're gonna get used to it. So if this is a little bit too much, a little bit too complicated, don't worry, it's fine. It's all good. We're literally gonna do this every single day. So to summarize, a branch is just an area where you do your commits, and you can switch to a different branch and do some different commits, or you can merge two branches together. All right, so we talked about dev, we talked about build. What about master? Well, finally, when I would like to release the game, release game, now I make sure that this code works, and now I merge dev into master. Master branch is usually the branch that's the most stable, that's ready for the public. Now, obviously, the public is not seeing my code. The public doesn't see my code. This is for me. This is only for me to organize my code. So now that's everything is ready. See, if by the way, we've never committed anything to master ever. We've only been committing stuff to dev and build so far, right? So now, after doing everything, and now it's ready for release, I merge dev and build. This is kind of the workflow that I usually use. I merge dev with build so that now build has the same exact commits as dev. So this is what? Release game, right? I build it, I test it, it all works. Now I can either merge dev with master or build with master. It doesn't matter which one, because both of them are now, they are the same. They have the same exact commits, right? But let's say I do build. So I merge build into master. We've never added any commits to master. Master so far has been completely empty, right? So now when I merge dev with build, all of these commits, all of these will be copied into master. And now master, the final commit, you can see here, the final commit is the release game, the stable game. So now I commit it. Now master is stable. It's a releasable game. I release my game. What if I want to do some more DLC stuff? What if I want to keep working my game? So now I switch from master back to dev. I switch from master back to dev, and in dev, I break my code. I add more features, DLC stuff. Once I'm ready to test it, I merge dev with build. I test the code. I build it, I test it, everything works. I would like to release to the public. Now I merge build with master. So now master is ready. So I can build the game finally and build it. And again, the entire idea is to split your code, to categorize your code. Dev is the most unstable code. Build is the stable code that can be used but not ready for release. Master is the code that's finally ready for release. Forget about staging. I don't want to talk about staging for now. It doesn't matter, right? So that's kind of the workflow that I personally use for all my software. Now we can have more branches, like I said. Let's say you're trying to experiment with something. Let's say you have your game and you decided we're making a 2D RPG game. Let's say one day I've decided to be like, okay, you know what I want to do? I want to try to give my main character a massive fucking gun. I want to add a gun to my character, and I want to test that feature. I want to see if it works. So what I do, I create a new branch, and I call this branch, for example, gun feature. So now I'm just writing some gun feature. I want to add a gun feature to my code. So I create the branch. and I write some code. I break the game. I test the game. I don't like the feature. The feature is not good. It doesn't feel right. So now what I can do is just go back to dev and ignore this branch completely. I never have to go this branch again. And this branch now has some code that dev doesn't. Dev had the stable kind of, it had the code without the gun feature, right? This was created as an experiment. I'm experimenting to see if the gun feature is nice. It wasn't nice. I don't like it. I will keep this branch. I'll be like, okay, I don't care about this branch anymore. I want to go back where I was. And so going back where I was working on the DLC, the feature that, or the code that kind of worked and I liked. So now I can continue working on my code without this code ever interfering with my dev branch. So now they're not related. And that's really cool. So that means you can create branches, experiment with features and ideas, and if you don't like them, you can just go to back to your original branch, which didn't have that feature. So now you can just ignore some part of your code and be like, okay, this doesn't work, I don't want to add it. Well, let's say I did like my feature. I like my gun, it worked fantastic. So now I can merge this code into dev. So all of this code will be copied and added at the bottom. This is like the gun stuff. And I can continue working. But in case I didn't like it, I can just ignore it. I don't have to merge it anymore. And again, merging is the idea of copying some commits from one location to the other. And so branches are really, really powerful. They're very useful. You can have multiple branches. Each branch can have a feature. Each branch can have a certain amount of commits and code that's either stable or unstable, and you can categorize and organize your code depending on how you want it. And so Git is extremely powerful when you're doing things like that. Hope that made sense. That's what our branches are. They're extremely useful. Now, the problem here that we currently have is if I go to Git-Fork, there is no branch. I am on a detached head. You never, ever, ever, ever commit on the head. The head, you can think of the head is no man's land. It's somewhere in the world that no one should ever be. And if you make a commit, you've done fucked up, and I can't help you. You can salvage things. The problem is with the head is that if you commit something there, you can't see it later on. You have to do some black magic to see them, and I don't have a lot of experience. I don't have that much experience in Git to see that black magic. So we want to make sure that we're not committing into the head ever. So the first thing I want to do is create a branch. So I'm going to go to branches. I'm going to create a new branch, and this branch I'm going to call it. Are you going to create a new branch for me? Well, apparently you're not going to create a new branch. Why aren't you creating a new branch? Is it because I have code that's uncommitted? Or is it because you're an asshole? Maybe I have to stage things. Can you create a new branch now? Looks like I don't want to create a new branch. Why are you not creating a new branch? Do I have to restart you? Question mark? Can you create a new branch now? You refuse to create a new branch. You are being unfriendly currently. If I commit you, will you commit to the head? I think you'll commit to the head. I don't want you to commit to the head. I don't think you're going to create a new branch for me. Will you create a new branch for me? I have no idea. I'm talking to myself. I'm going crazy. Please create a new branch. I'm fucking begging you, create a new branch. New branch? Excuse me. Okay, it doesn't want to create a new branch. I'm gonna press on commit and try and see if it's gonna commit on the head or not. If it commits on the head, I'm gonna lose my fucking shit. Ah, okay, it created the branch for me. Okay, I didn't, thank God, I didn't lose my shit. Okay, so by default, it's gonna create the master branch for you. Okay, so this is kind of nice actually. So it's made a new branch called the master branch, which we talked about, right? So my initial code, I know it works, was committed here. And you can see there are a lot of details about this. First, you can see my picture. you can see my name, who's the author who committed or who worked on this code. Are you gonna work? Are you gonna be an asshole? Looks like you're gonna be an asshole. Can you not be an asshole? It looks like it wants to be an asshole. Do I have to restart? What is that? Do I have to restart you? What is going on? Epic Pen, please work. Are you gonna work? There you go. Good boy. Okay, so notice this is my commit right now. This is a single commit in my code. You can see the title of my commit. You can see which branch it's on. It's on the master branch. You can see the author of this commit. That's me. You can see my picture. You can see the ID of the commit, which is, this is the ID. This is the SHA ID. Right? And it only displays the first 1, 2, 3, 4, 5, 6, 7, 8 characters or 8 letters. You can see the date of commit. Once you click on the commit itself, you can see there's more detail. The author, the name, the email address, the time and date, my picture. For whatever reason, this picture is not the same as this picture, but whatever. The ID of my commit, the description of my commit, and the really cool part is that if you scroll down, you can see exactly what was committed. All the files that was committed in here are saved here. And the really cool part is that if let me search for main. So this is RPG main. If I expand this, I can actually see the code that was added. All the green lines means this is code I added brand new. So you can see all of this code was committed and saved. Right? That's really, really awesome. If I want to see Git attribute, you can see all the Git attribute code. So you can not only see the commit title, name, description, you can actually see the files and the file contents of what was committed, which is super cool. So now I have my master branch. Now I'm done. That's it. I've done it. I've committed my code. It is now being tracked. It's now being saved. Finally, we're done. Well, not quite. See, I would like to push this code now online. I would really like to push this code online. So we're gonna have to set this up. And this is now 2.5 hour lecture. I'm sorry for whoever watching this. I think you're gonna have to watch a little bit, stop, come back, and so on and so forth. But before we're done, the last thing, I would like to push this code online. Alright, so let's push this code online. I'm gonna close Visual Studio, don't care. But the important part is now I have my master branch, which is cool. Okay, so how do I push this code online? Well, to push this code online, I need to go to my GitHub, right? This is your account has been flagged. Because of that, your profile is hidden from the public. If you believe it's a mistake, contact support to have contact status reviewed. Because of that, your profile is hidden. Okay. I don't care about my profile picture. They flagged my account. Is it because David ate his dog? Is it because I named my account David? Get up. You have problems with me? Hi, David ate his dog. I'm interested in. I'm currently learning. I'm looking for collaborate on how to reach me. You can have a readme file here. Anyways, I don't care. Okay. Well, here's the thing. So I've created my repository locally, right? I have done everything I need to do locally, which is fantastic. Now I want to push my code online. To push my code online, I need to create a repository online. Okay, so I'm gonna click on create repository. I usually, or not usually, you should name the repository exactly what you named it locally. So RPG/game. Okay, I'm gonna make it private. Actually, well, I'm gonna make it private. Doesn't matter. I'm never gonna commit it. I'm never gonna commit this in here, because I'm gonna commit this in my actual account that you guys can check out. This is just a temporary account that I'm just gonna delete later on. But I'm gonna make it. So I'm gonna make it private for now. Just for now. Okay. So repository, same name. Don't add a description. don't add README, don't add README file, don't add a gitignore file, don't choose the license. None of these, because it's gonna create a problem if you add them while I'm trying to push the code for the first time. So usually this is the process of usually how it happens. You create the repo, you create it online first. Once you create it online, you clone it to your machine, and then once you clone it to your machine, you can add files and push it. But we've done it completely reversed. What we've done is we created the repository on our machine, local machine. And now we have to create the repository again online, and we have to merge those two repositories together and kind of communicate. So that's kind of, I went the hard way. What you usually do, again, create the repository online, and then you clone it to your computer. Coding is not the hardest part. Yeah, I would say so. I mean, Git is a little bit overwhelming when you first start, but once you use it over and over and over and over, it gets much easier, honestly. All right. So again, I should have created the repository online first, but whatever, I didn't do them. So now, if you add these files, you were gonna have an issue trying to merge my local repository and online repository together. But if you create it online for the first time, you can just add these, no issues. I can choose a license, by the way. If I choose a license, I don't know, that will create a file for me. Never mind. Okay, so I shouldn't do that. All right, so just make sure the name is the same as RPG game, and create repository. All right, so I've created my repository. And it's private. You can see there's a lock here. That means it's private. And now I have two options, HTTPS and SSH. And there's a bunch of links. And there's all the commands that you need to clone this or use this in the command line. Since we're not using the command line, we kind of don't need these. All right. Now the question becomes, Jesus Christ. The question becomes, what the fuck is HTTPS and SSH, and why are they different? All right, another lesson. Oh boy. So, going back to this lovely thing. Whenever you visit a website, right, like youtube.com, right? This is your computer, client. This is the server. Essentially, what happens when you do www.youtube.com and press enter, well, a lot of things happen, and I don't want to get into too much detail. I will get into detail when we do multiplayer. But for now, this is already a 2.5 hour lecture. I want to kind of skim over this a little bit. So what happens when you visit YouTube? Well, the client, your computer, your web browser, Chrome, Firefox, Edge, whatever web browser you're using, it sends a request to YouTube server. So this is YouTube server. It says, hey, give me web page, please. So it asks the server to give us, the client, a web page, the HTML web page, so we can see what's going on, so we can see what is on YouTube. So we call this a request. So we're sending a request telling YouTube server to send us the web page. The response, YouTube is going to respond to us and give us the actual HTML file that we're going to render on our web browser. That is very brief. There's so much in between. There are DNS servers, there's so much in between, stuff in between. There's handshakes, there's a bunch of things which we're not going to talk about or cover. But this entire process that we've done is done on a protocol called HTTP. HTTP, Hyper Text Transport Protocol. Hypertext Transport Protocol. HTTP is a protocol. A protocol is just a set of rules for two devices to communicate between each other, right? So for example, the protocol between me and meeting a stranger for the first time is say, hi, my name is David, and I shake their hand. My name is not David, by the way, but I shake their hand and say, hey, my name is David. That's a protocol. That's a thing that humans know how to communicate between each other. For these two guys, two computers to communicate between each other, they need a protocol. The protocol is called HTTP. All right, so protocol is just a set of rules for two devices to communicate over a network, or online, or on LAN, over a network. Okay, that's HTTP. Now, if you go to Git, this is HTTPS. So what does HTTPS means? So there's an extra S. S stands for secure. So hypertext transport. What is H? I forgot what HTTP stands for. Hypertext HTTP. Hypertext transfer protocol. Hypertext transfer protocol. Jesus Christ, I'm so okay. Hypertext transfer protocol, secure, and S stands for secure, right? So the problem with HTTP alone, the problem is if you, the client, this is you, are connected to a Wi-Fi network that is unsecure, and an unsecure Wi-Fi network is anywhere, and in an airport, in a restaurant, anywhere public, right? You're connected to a Wi-Fi network, and you are communicating between two websites. For example, here, your computer communicating between your computer, and instead of YouTube, let's say the bank. Okay, and you're sending your bank, instead of sending the bank, hey, I want your web page, you're sending your bank your username and password. And if you imagine if someone in the middle, a dude in the middle, a creepy ass dude, right? He's angry, right? If he's in the middle in here, reading your requests and responses and seeing all the traffic, everything you send to the server, he is seeing everything you're sending to the server. So basically, he is seeing your username and password. If he is there, that is really, really bad. That is super bad, because now he has the username and password. He can literally see everything you're sending to the server and everything the server is sending back to you, right? And he can see username and password. This guy, or this method, is called middle or in the middle man attack. So this creepy ass dude, he's in the middle. He's somewhere here. He's intercepting your connection. He's looking and reading your messages, right? And he can do that because he is also connected to a public network, that same network you're connected to, and he has special tools to read what you're doing online, right? Because here's the thing, this is your router, this is Wi-Fi, right? And this is your computer, PC, and you're sending data, you're sending actual messages in the air. So you're literally sending messages in the air. So if there's a computer here, he can read these messages. They are in the air, right? They're unsecured. He can just grab them, and that's possible if you have the right software, right? So this is really bad. This is really, really bad. Okay, let's change up the scenario a little bit. What if everything happens, the same exact thing happened, but now you're connected, or now you're visiting a website that's using the HTTPS protocol. Well, now, when there's still a guy in the middle, he's still looking at your traffic, right? We're still connected to unsecured network. But now, whenever you're sending your username and password to the server, they are encrypted. This data is now encrypted. So that means even if this guy is reading your packets or reading your data that you're sending to the server, which is fine, completely fine, even if he's doing that, he's not going to make any sense of them because they are encrypted. And the only person that can decrypt them is the server. Right? So that's why we use HTTPS. And that's why every website, if you go and visit any website over here, you can see there's a lock over here. And you can see that this connection is using HTTPS, the HTTPS connection. And if I go to YouTube, YouTube is using HTTPS. If you're using a website that's unsecured, so I don't know any websites that are unsecured. So I'm going to go HTTP website. Let me see if I can. Here's an HTTP website, right? You can see you have a big ass warning message that says this is unsecured. Your connection to this site isn't secured. And if I look at this, if I copy this, the URL, if I copy it and kind of paste it in here, like in my Notepad, you can see that's HTTP, not S, it's HTTP. And that's unsecured and unencrypted, and that's really bad. So that's what HTTPS is in GitHub. I'm basically connecting to the GitHub server securely using a username and password. All right. The problem with HTTPS, well, there's no problem with HTTPS. HTTPS is great, but small inconvenience is that every time I push my code and every time I connect to the HTTP server, I have to put my username and password. And if someone has your password, they can access your data, and it's just really bad. And by the way, you should always enable two-factor authentication. You should always enable two-factor authentication on all of your accounts, right? Don't rely on your password, please. Never, ever rely on your password. Like, I literally showed my password on stream today. I'm not worried because I have two-factor authentication. I'm going to go and change my password anyways on all my apps now that I have showed it because I'm a dumbass. But I'm not too worried. I'm not doing it immediately because I have two-factor authentication. If someone just tries to enter my password and my email, doesn't matter. He still has to go through two-factor authentication. A special code that is with me, right? So please enable two-factor authentication on all of your accounts. That's really important. Don't rely on your password alone. So with HTTPS, you have to write your username and password, and it's really annoying. So instead of doing that, we're going to use something called SSH. And SSH doesn't rely on username and password. It relies on two things: a private key and a public key. All right. So now the question is, what the fuck is a private and a public key? Well, I'm so glad you asked. I am so sorry. This lecture is now 2 hours and 50 minutes. This is the last thing before we're done, I promise. All right. HTTPS requires you to enter your username and password. Right? And it's annoying, and if you rely on that, someone can just enter username and password and they can take your account over, which is really bad, not great. SSH, on the other hand, is a protocol. And remember when we talked about protocol, we said it's a set of instructions that two devices can communicate between each other. Not instructions, a set of rules, right? So SSH doesn't rely on username and password. It relies on a private key and a public key. So again, what the fuck is a private public key? Well, let me give you a scenario. Okay. Let's say you're here. This is you. Look at you, happy. You're enjoying the world. You're so naive. You don't know that your life is gonna end in a few minutes. I don't know why I tapped 13. You're enjoying your life, and you're happy, right? You would like to communicate with your best friend. You want to send a message to your best friend, be, hey, dude, how are you? How you doing? It's been a while. We haven't played for a while. Can we play some video games? You're busy? Okay, cool. Sad. Cool. You want to talk to your best friend, and you want to send him and he's an idiot. We all know he's the biggest idiot in the world. We all have that best friend who's like always getting in trouble and just a moron, right? But we all love him because, well, he's our best friend. He's a fantastic guy. You would like to send him a message, right? And the internet wasn't invented yet, so you want to send him an actual letter, right? Because apparently this is 1320, right? So you want to send him. Apparently this is the Dark Ages for whatever the fuck reason. So you want to send him a message, right? You want to send him, "Hey, dude, I miss you." And you want to also write in that message, you have some sensitive information. Let's say it's your bank account. And apparently in the Dark Ages we had bank accounts. I don't fucking know. You wanna put your bank information, or you wanna put something sensitive in that message, right? So what do? You can't just send the letter this way. You can't be like, "Hey, yo, take this letter." Someone, the delivery guy or the mailman, and apparently in the Dark Ages there were mailmen, might take this envelope, open it, right? Again, he's our evil guy. No one likes him. He's getting in trouble. Apparently, he has 3 eyes for a fucking reason. He's the mailman. He opened the envelope, read all the information. Now he knows your secret, and he can destroy your entire life, right? We don't want that to happen. So what we need to do is encrypt this data. The problem with encrypting this data is this idiot is not going to be able to decrypt it because, well, he's an idiot. So, for example, in this message, I say, "Hey, man, I love you. You're so great. Why don't you talk?" Okay, why did you're just it's a secret message you're trying to send to the guy, right? All right, you want to encrypt this data because it's really embarrassing telling your best friend that you love him for whatever reason. So what we do is we have an algorithm to decrypt this data, and this algorithm basically says that if the letter is H, you give the number 7. If the letter is E, small e, you give the letter A. If the letter is Y, you give the letter 5. If the letter is M, I'm gonna do this entire thing. If the letter is M, you do 2. If the letter is A, you do 5. We already have 5, sorry. We could do 6. If the letter is N, you do 9. All right, and if the letter is I, capital I, let's do it here. If the letter is I, you do 99. If the letter is L, capital L, you do 55. If the letter is O, you do B, capital B. If you do V, then the letter is C. If you do E, have we used E before? E is A. Okay, and then the Y is 5, already used it. O, already used, capital B. And then U, we've already used U somewhere. Love you. No, didn't use U before. Okay, U is Z, right? And the exclamation mark is underscore. So now what you're gonna send to your friend is this: 7A5 269 9955 BCA S, or is this 5 or S? This is 5. 5BZ underscore. So this is my encrypted message. Right? I've encrypted my message. Done. It's encrypted. And I write this in, this is what I write to him. Right? And I send it to him. Now he's a big idiot. He's not gonna understand what in the fuck does this mean. He's gonna be like, is this guy high? Is he on drugs again? Jesus Christ, we had an intervention just last month. Dude, what is it? And, he goes on a rant. And so you're like, so you send him that message, right? The problem is he needs to decrypt this. And he's not going to be able to without what 7 means, right? We know that 7 means H, A means E, 5 means Y, right? So when he sees 7, right, he replaces 7 with H. When he sees A, he replaces it with an E. When he sees 5, he replaces it with a Y. So he decrypts this message by typing all these, right? All right, cool. But he doesn't know that. So what we need to do is send him another, after we send him this, we need to send him another letter explaining to him in some detail on how the fuck are we gonna decrypt this message. Now our mailman is still angry, he hates the world, and he sees the envelope. So what does he do? Well, he opens it and he reads it, and now he read the first envelope, and now he reads the second envelope, and he now he knows how to decrypt this message. And now this guy is sad, right? And this guy was even more sad because they both know, they both, well, this guy stole their information, both of their information, or this guy stole this guy's information, right? So this is a really lousy way to do it, because we sent the message encrypted, but then we send the password on how to decrypt the message, and that's really shit. This is a shitty way of doing things. Well, what if instead of doing that, what if actually instead of sending the actual letter and the password in two different envelopes, what if we do this? So what if now this guy is over here, right? This guy's over here. What if we do this instead? This guy is gonna send you a box, right? A box with a lock that is open, right? This is a box and a lock, an open lock. He gives you this box and he tells you, hey dumbass, if you ever want to write me a message, put the message in the box and lock it with this lock. Okay, fair enough. So he sends this, the mailman. This is the mailman. He's angry. He hates his life, right? He delivers the box over here. He delivers the lock, right? The lock got fatter for whatever reason. The lock has been eating on the way. Jesus Christ, you really need to lose some weight. We put the message here, and then we lock this box, right? We lock the box over here and with the message inside. And then we give this to the mailman, and the mailman gives the box to this guy. Now, the only way the mailman can see the contents of this box is to break the lock, which both these guys are gonna know that he did it, and they're gonna basically murder him. I do not condone murder, please don't do it, but that's what they're gonna do. So now the box is locked. The only way to open it is with a key, a special key. This key, this guy only has that key. So now, no matter what the mailman tries to do, he can't open it. So this guy can just use the key and open the lock, which is a brilliant idea. Instead of sending a box, instead of sending a message that's encrypted and a way to decrypt it, you basically now, this guy is sending you a box on a lock, and you're putting stuff here, lock it, and sending it. So there's no way for this guy to access it. And that is the entire concept of a private and a public key, right? The public key is the box with the lock that's still unlocked. This is the public key, right? The private key is my actual key. The key that unlocks this box or unlocks this lock. So this is my private key. The private key, only I use this private key. No one has access to this private key, because if someone has access to this private key, they can open any lock I send, which is a really bad idea, right? So now, maybe there's a way to do that, but that's a little bit I don't think so, no. So anyways, so this is your private key that you only have. No one has access to this private key, right? And let's say this is the public key. So that's the entire point of a public and private key. This guy will send you his public key, right? So in this case, let me actually put the private key over here. This is the private key, and this is his public key. This guy, private. So this guy over here, he owns both the public and the private key. He can share the key publicly with anyone. He can give this to anyone in the world. It doesn't matter. They can take it, use it, do whatever the hell they want. Right? So the public key we share, and we share it with anyone. With this case, we're sharing it with our best friend. He puts the message, and he encrypts the message with our public key. The only way to decrypt this message and to open this lock is with my private key, which I never give to anyone. And that's the entire idea of a public and a private key. So why am I explaining this? Well, with SSH, we need to create two keys, a public key and a private key, right? The public key is going to go on GitHub, and the private key is the one on my machine that I never share with anyone. So rather than using a username and password, now I'm using this concept, a public and a private key, which works fantastically. It works really, really well. And that's how SSH works, and that's even how HTTPS works. In terms of, okay, I don't want to confuse you too much because I said HTTPS requires username and password. But in terms of visiting a website, when we actually visit a website, we use public and private keys. But in the case of GitHub, we use our username and password, so I don't want to confuse you too much on that. But yes, SSH, we use public and private key, and that's the concept. That's the entire concept of what a public and private key. All right. So now the question is, how do we generate a public and a private key? Well, simple enough. If I go to Google, and let me close all these tabs. Actually, I might need some of, let's not close them. All right, so if I go here, google.com, I'm gonna type generate SSH key GitHub. All right, so search this, generate SSH key GitHub. The first link that shows up is the docs.github.com, which tells you how to generate an SSH key. You click on the first one, the first link, and you're going to see this line of code and this line of code. This generates an SSH key and a public and private key, and this also generates a public and private key. However, this, if you're using a legacy system that doesn't support ED255F1 algorithm, use this. This is the old way of doing it, or it's going to use an old algorithm, which is not great. We're going to use the newer algorithm. Right? This is uses RSA algorithm. This is uses ED25519. So let me zoom in so you can see it a little bit better. So now what I'm going to do, if you open the command line, either the command line or even git bash, I'm going to do it in git bash. So what I'm going to do, copy this. Okay, first, before I start, I want to back up my own SSH keys because I have my own SSH keys and I don't want to lose them. So I'm going to go to users, my username, and here are my SSH keys. I'm just going to rename this to backup. Okay. Okay, so I'm going to copy. You don't have to do this because you won't have an SSH key. So I'm going to copy this line, go here, and right-click and paste it. Let me zoom in so you can see this. All right, so now what I want to do is delete the email and put your actual email. Shit, where's my email? Where's my fake email? Fake email. Fake email. Here's my fake email. All right, so I'm going to use this fake email. Oh shit. In here, I used my actual email, not my fake email. I don't think it matters. I actually don't know if it matters. I don't think so. Anyways, I'm gonna use my fake email. So I'm gonna right-click, paste it. So this is how it should end up. SSH dot keygen -t ed 25519-c and your email. Right? Press enter. Now it's gonna tell you where do you want to save this. The default directory is fine. So press enter. It's gonna ask you to put a password. So you can put a password on your SSH key. I'm not going to do that. I can't be bothered. So press enter. And it's going to ask you to put the password again to verify it. enter, and this is my SSH key right here, right? So now to actually open it, what I'm gonna do is go to the same location. So you want to go to this PC, go to your C drive, go to your users, go to your user folder. Your user folder is going to be different. For mine, it's going to be Conta. Whatever your Windows username is, go there. And then open the .sh folder, which is this. And you're going to have two files. This is my public key, and this is my private key. How do I know this is my public key? Is because it ends with .pub. All right, so what I'm going to do, now that I've generated my SSH keys, I'm going to, in GitHub, I'm going to go to my profile, go to settings. In settings, I'm going to scroll down to SSH and GPG keys. And then I'm going to click on new SSH key, not GPG, SSH. So new SSH key, click on that. Now it's going to ask me to put a title. So I usually just put my computer name. You can put whatever title you want. I'm going to say VV desktop. So I usually name it with my username and whether this is my desktop, laptop, Mac, phone, whatever. So VV desktop. And I need now to copy the content of this file in here. So I'm going to right click on it and click on open with. And I'm going to select Notepad. This is my public SSH key. This is safe. I can share this with anyone in the world. It doesn't matter. Right? What I shouldn't share is the private key. So I'm going to select all of this, copy it, Control C, and paste it, Control V. Add SSH. I need to put my password. What's my password? David ate his cat 99. Confirm password. And there you go. I've added my SSH key. So that part is done. Now, in Git-Fork, I need to tell Git-Fork where to find my private SSH key. To do that, you go to File, Configure SSH key, and by default, it should be able to find it in this location, C users conta.sh, and can find it on its own. Right? So all you have to do is checkmark this, and click on OK. So now Git-Fork is configured. It knows exactly where my private SSH key is. By the way, if I right click here and I click on edit, and I can see the contents of my private key. It's the same. It's just text, right? But you shouldn't show it to anyone. I'm gonna show it. It doesn't matter because I'm gonna delete these SSH keys. But this is like the private SSH keys. Right? These SSH keys are mathematically linked between each other. You cannot decrypt a message with a different private key. So that's kind of something to remember. All right, so fork now is configured. GitHub is configured. Now it's actually time. So I'm going to go back. I'm going to click on the cat over here. I'm going to go to my repository. I'm going to select SSH. I'm going to copy this URL by clicking on here or selecting and going to copy like this. Right? You can see the remote section. I'm going to right click on remote, add a new remote, and then the cool thing about Git-Fork, it pastes the thing on its own, right? I'm gonna click on test connection just to make sure it works. It says connection successful. I'm gonna click on add remote. Cool. So now that worked. Okay. Now what I want to do, now I've configured everything. My repository is connected to GitHub. All right. I can access GitHub through my private and public SSH keys. Everything is linked. This repository is linked with this repository because I right-click on remote and I click on add remote. Every repository has a special link. You can see that every repository will have the repository name and my username and where this repository exists, which is on GitHub. So it exists on GitHub. The repository has my username, and this is my actual repository. So when I clicked on right-click on remotes and I added the remote, I basically told it where this repository exists online. So now that they're both linked together, I can click on push, which basically means it will take this commit and push it online. So if I click on push, and then it's gonna push the master branch to the master branch in GitHub. Click on push. I can click on this for more details. You can see a little bit more details. This icon over here. Wait for a while, and it says uploading LFS object. Rate limit exceeded. Failed to push some reference to Git. Why? Let me refresh this page. So it didn't push anything, because if it pushed anything, I would have seen the code, but sadly it didn't. Okay, I'm gonna click on push again. This time I'm gonna say force push. So let me see if that works. Nope, same issue. Rate limit exceeded. What? Why? Does GitHub not support? No, GitHub support LFS. Alright, maybe because they blocked my account. Because my account is very suspicious with a suspicious email. Hey, the server message means that the server side has rejected your connection because the client made too many requests in too short period of time. We're tracking potential improvement. Okay, well, I definitely didn't do that. Okay, I honestly think just because my account is like it's very suspicious, right? So what I'm gonna do, I'm gonna actually push this to my actual account. So I'm gonna delete this. I'm gonna go back to my original SSH keys, which GitHub knows about. I'm gonna actually sign in to my actual account, which is over here. So you shouldn't have that problem, hopefully. I think it's just on my end. But just to verify this, I'm gonna do the same process that I've done here. So this is my actual account. Gonna create a new repository. Let's say RPG game. Name it the same repository. Make it public for you guys to see. Create the repository. Already SSH configured. So SSH, just clone this, copy this. I'm gonna edit the remote. You don't have to do this, only me, because I think I messed up somewhere. Test the connection. Succeeded, add remote connection. Actually, I need to remove the previous connection first. So delete remote, add remote, test. All right, make sure SSH is configured correctly. Configure SSH, yeah, everything's configured. Now, if I click on push, hopefully this should push without issues. Moment of truth. Moment of truth. Is it gonna work? Please, I beg of you, work. We are 3 hours and 15 minutes in. Please work. People want to go home. Please. Come on. You can do it. You can do it. You can do it. You can do it. Jesus Christ, why are you taking so long? You can do it. 1. Hey, there. Cool. It's pushed everything. So just because my account was suspicious, because who the fuck would name their account David ate his dog? Like, what the fuck is wrong with people? Now I know that this is pushed. How do I know this? Few reasons. 1, you can see the GitHub icon over here. 2, in origin, if I expand this, you can see that the master branch exists now. This basically says that the master branch exists on GitHub. And the third way I can verify this is if I refresh this page, I should see my code here. So refresh. You can see all my code that's online, right? So now, anytime I commit code, you guys can go to GitHub, clone the code, and kind of check it out, right? Which is cool. And you can see that there's one master branch. So now what I would like to do, add a secondary branch. I want to add 2 more branches, and then we're literally done with the stream. That's everything I want to talk about Git. So go to repository, new branch. I'm going to create a dev branch. I usually like to have my branches lowercase. I'm gonna click on checkout after create. That means I'm gonna be on that branch. When I check out branch, that means I'm on the branch. How do you know you're on a branch? Is because it's bold. Whenever the words are bold, it means that you are on that branch. So now I need to push this branch also online, because you can see in origin there's only the master branch. When I created the branch, it only created it locally on my machine. So I need to push this dev branch, right? And if it pushes, it's dev branch is gonna show up here under origin. So you give it a few seconds, and you can see it did show up, or here dev. And now I click here, I only see master. If I refresh the page, click again, now I have master and dev, right? I'm gonna create one last branch, which is my build branch, which I use. Create and checkout. Created my build branch, push, push. It should show up over here. Give it a second or two or three. There you go. I have my build branch up here. Again, these are two branches. If I refresh, it should show up all three branches, which it does, right? Now, if I want to move from one branch to the other, I can just double click on it. So double click on dev. I'm now in dev. I know that because it's bold. If I double click on master, now I'm in master. Now, here's the thing. This commit exists in all three branches. So that's why you only see a single commit on all three branches. So I'm gonna go to dev. I always want to stay in dev, and that's it. Git is configured, GitHub is configured, all this works, and now if I want to give you this code, you can have it and use it. One last thing, I want to show you how to clone it if you need to clone this code and use it for yourself. To clone the code, I'm gonna give you this URL. So you're gonna visit the URL, you're gonna go to clone, and then go to SSH and copy this. Now, for this to happen, you're gonna go to File, Clone, and then it's gonna paste the URL by default, which is super cool, but you can paste it if it didn't do that. Select the location where you want to clone this. So I would like to clone this in my C drive. I'm gonna clone it in. Gonna make a new folder called delete me. All right. Gonna select this. This is the location. I'm gonna go to this folder right now so you can see what's happening. So if I go here, users, conta, delete me. All right. Click on clone, and should now see it's cloning. If I open the file, it created the .git, and now it's cloning all my project. Now I have my project in two location. Well, I shouldn't have in two location, but if you want to have it, you can do that same process. Now, once it's done, it's gonna download all the LFS files. So first it clones the source code, and then all the LFS files. Give it like an hour or two. Or a minute or two. Come on, let's go. Jesus Christ. Okay, so now it's filtering content, which means it's downloading the LFS content, I think. Probably. No idea. I think it's downloading LFS. So if I go to RPG game, you should see this is my source code that exists over here. But in dependencies, I think it's still downloading. So if I go to my lib, yeah, it's only downloaded 3 lib library files. Give it a second. It should download some more. Come on, 12%. There, more files are appearing. 16%, 20%, 24%. It's cloning everything. Everything and everything. Can we let's go, please? Please. Alright, it's downloading more stuff. 44%, 48%, 50, 60, 72, 84, 88, 92. Come on, you can do it. You can do it. I believe in your computer. 100%. Woo! All right, and there. I cloned the project. Now, here's the thing. When you clone the project, you are not allowed to push to my project because you don't have access to my project. You can only push if you own the project. And so seeing that you guys don't own the project, you can't push. You can only pull, but you can't push, right? So that's just something to keep in mind. All right, so I showed you how to clone, how to switch repositories. We're going to talk about Git a lot more and get used to it a lot more. But that was like a massive crash course on SSH, HTTPS, Git, repositories, GitHub, all that stuff. It's really important to you guys use Git because as a software engineer, you're always using Git. You're always committing your code. You're always pushing your code because if you break your code and you wish, like, you want to go back in time to when it wasn't broken, and if you weren't using GitHub, you would have wished you used GitHub, right? So it's really important you have GitHub set up and all that. This might have been boring. There's a lot of stuff that I covered, but it's really essential you get used to it and kind of use it all the time. The entire world, every software engineer uses GitHub, or not GitHub, or Git of some kind of form, or some form of version control system, right? With that in mind, that's all I want to cover. That's it. We're done. Now, next lecture, we can go back to actually making the game, the actual game that we're here to do, right? But the cool thing now is that I have a feature. Anytime I write some code, I can push it online. You guys can check it out, or I can just. The reason I did this just because it's backup. It's backup online, and I can go back in time. But it has the added benefits of you guys can clone it and check out the code too, which is cool. Anyways, that's it. That's all I want to cover. I'm so sorry for taking so long. Thank you so much. I will see you guys tomorrow, hopefully. And yeah, take care. Sayonara, arigato. Bye bye.